please mail to me. I will send you the format. So in that Excel, you have the names. So that name, the list, what you can see in the website, take that and paste it as such, and take attendance from your participants twice, morning and afternoon. So I have put the dates and the dates also there, and for the signature they can do it. If your participant is online connected from the nearby college, in that case a coordinator can countersign for it, and at the end you can write these participants are connected online. Okay, so this is for the coordinators, and see that on Friday evening. By that time, say, oh, everything is ready, you have to just scan and send me that copy. Okay, so that is one thing what you have to do. All the coordinators, see that you do that. And on the last day, there will be a feedback session in the afternoon on Friday. So that feedback form also all the participants have to fill, and there will be a small MCQ based on all the things what you are learning. It's very simple, but there is nothing to do with certification. You will be getting the certificate if you have 80% attendance. So these are the things which I have to remind all the coordinators, and please, coordinators, take care of all these things. So now let us move on to today's lecture. And
good morning, madam. I am
yeah.
also here from Parul University, Baroda. So kindly acknowledge our attendance.
Yeah. Okay, Parul Institute, I called, but yeah, I think that time you were
No,
not.
but madam, today is a year election is there. We are in the full day is there.
Okay,
That's why.
no problem. I was calling in between, then I didn't find. Yes, sir. You can just introduce your institute and give how many participants are there.
Well, Parul University is as a university largest in terms of number of students in the Gujarat state. We have more than 30,000 students, including from engineering, pharmacy, medical, paramedicals, and others are there. As an institute, Parul Institute of Engineering Technology, Department Analytical was established in 2003, having a capacity of the 22 faculty members. And we are running with the state laboratories, and most of we have 15 people with the PhD doctorate level, and all are working in their area in the well expertized manner. More than here, I have not got the list, but more than 20 people have participated, including all these things. So I will inform you later, madam.
Okay. Thanks a lot, sir.
Thank you.
Yeah, thank you for introducing your institute. So any other colleges left? You are connected, because I was just all the 22 colleges. I just went through the list, but somebody was missing in between. If you want to give an introduction, you can give. College of Technology and Engineering, Udaipur, Rajasthan. Are you there? Then EE-AIKTC, Navi Mumbai. Okay. So I think with this, let us move on to our today's.
Good morning, ma'am.
Yeah, yes, sir.
Good morning, ma'am. I am Mandeep Guleria,
Yes,
working as assistant professor in Department of Electrical Engineering in TSDC Institute of Hydropower Engineering and Technology, Uttarakhand.
Okay, yes, sir.
So I am very grateful to be part of this workshop, and I am looking forward that this is going to be very fruitful for me in my research work.
Okay, sir.
Thank you.
Thanks a lot. So apart from that, yeah, I forgot to welcome the participants from NITTER, like those who have connected online. So I also welcome those participants, and there are more than, I think, 70 to 80 participants who have directly registered under NITTER. So those participants also, I welcome you all. So now, without wasting much of the time, let us move on to today's lecture. And like Gopal, are you there? Actually, in between this share option, admit option is coming. Can you remove me from that? Gopal, can you hear me? Because every time now this admit option is coming. I think you can just you can make only the FDP 36 as a coordinator. I think you have made me also, so that because of that, these, when the participant enter and leave, I could also see that it may be disturbing in between. Is Gopal there? Can it be removed? Okay. Anyway, after this, we'll check out. So So today we will be seeing the topic electric vehicle technology. That is the basics and standards we are going to see. And first of all, let me introduce myself because many new colleges have also joined this time. So I am Dr. Shimi Sudalata. I am assistant professor in the electrical engineering department at National Institute for Technical Teachers Training and Research, Chandigarh. And telling about myself, I was born in Kerala, brought up in Tamil Nadu, and after my marriage, I came to Chandigarh here and I started doing my PhD here from Punjab Engineering College, deemed to be university, PEC. And at the same time, I joined NITR, National Institute for Technical Teachers Training and Research, and as an assistant professor. And once I finished my PhD, I got an opportunity to go to Sweden and do a postdoctoral research in the field of electromobility. So that was a close thing for me why I choose this STC itself. So I was working under Professor Matt Bolin. So I was supposed in the Luleå Technical University in the electric power engineering group. And in foreign countries, if you see, this technology has come out, and there I could see in nearby places also, lot of electric vehicles are there. They are charging, and even the climate condition is so worse. In that also, -30, -40, also the electric vehicle is successful there. Because that was there in the mind that, like, say, in such a, even like we thought, like, well, we'll get a two-wheeler. So thing which comes to our mind is, oh God, battery get because our mobile also we can see suddenly the battery get discharged. So in such a condition, what will happen? Will our, like, in this -30 or -40, my battery will be able to withstand, and after going sometimes it stops. What will we do? So that was the thing always which was coming to my mind also. But after going there, staying in -30, -40, and I also got an opportunity to drive Toyota Prius. When for 2 years when I was there, I was using that vehicle, and I could say that never the vehicle has stopped anywhere, or I have not got any problem. That was a second-hand vehicle which I got, more than 10 years old. So still, that gives a confidence for me also to say that this electric vehicle technology is one of the promising technology, and there is nothing to worry about. And in future, this is the field which is going to be, like, all vehicles will be replaced, and it will be replaced with a electric vehicle only. So you can, when those who are in the process of getting a new vehicle, you can close your eyes and go for it. It is really a promising technology. Okay, so telling about that, the group with which I worked is Luleå University of Technology, Electrical Power Engineering Group. The group mainly works with topics like power quality, low and medium voltage, electricity market, transmission system reliability, and electromobility. So I was mainly working with these two areas. So that's why I've taken my topic also like that. And this is Professor Matt Bolin, along with whom I was working, and we have Sarah also in the group. Why I want to introduce them is every 6 months they advertise PhD and postdoc positions, and if you have a good like research background, like, what they see is, if you want postdoc, you should have, after your PhD, you should have worked, you should have done research. Or those who are willing to do their PhD, if you have a very good background of doing research, more than papers, they want very good research also, and good, like, if you have good papers, that's a very good opportunity. And not only in Sweden, in many European countries, I have seen they have very good opportunities, and straightforward, you have to just apply, and if you have a very good background, surely you can get into it. Okay, so just that's why I want to give an introduction about this. And after my 2 years of my postdoctoral research in electromobility, I had returned back to here, NITR. And my main area of research in NITR, or before also, was mainly I was in the area of power electronics and drives. Then I do soft computing, like the optimization, GA, PSO, and other optimization, artificial intelligence, fuzzy logic. So these were some of my area. Then apart from that, renewable energy, my PhD was in the area of maximum power point tracking and inverters, multi-level inverters. So a little bit of renewable energy and facts and all those things also we have worked with. And apart from that, now I have shifted to electromobility, power quality, with grid integration of EVs and other power quality issues. And apart from that, my interest has now gone into big data analytics for the smart grid area also. So these are some of the areas which I am working on. So going to today's topic, so we will be going into some topics like why EV, then the vehicle to grid integration, machines and energy storage systems, a general introduction, which we'll go into depth in tomorrow's lectures. We have experts connected to us. Then challenges in EV integration with the power grid, then standards and regulation, and some of the prototyping, as many of them also had told. We also had done some small prototyping, which actually gave me an opportunity to work on the field of electromobility. So those things also, for basic understanding, we will be taking care. So like we were all telling about that, say, yeah, electric, before this electric vehicle in 1886, it was Carl Benz, which who came out with an electric vehicle, not an electric vehicle, sorry, a petrol based vehicle. And it's a motor wagon. So you can see that picture here. And that was in 1886. You can see here it is a little smaller. If you want, I can just expand. So here in 1886, you can see this car came, that is Carl Benz had come out with this model of not the electric vehicle, sorry, the petrol operated vehicle. But before that itself, before that in 1884, this Robert Anderson first built a like electric carriage, but he was not as such recognized. It was Thomas Parker in 1884 was credited with the first production of electric cars in 1884. So you can see that before this petrol vehicle came, the electric vehicle was there. Okay, then what do you feel that though the electric vehicle was there before this internal combustion engine, then why this technology didn't pick up, or what made it like stop there itself, or the growth was not so high? What might be the thing? Can any participant tell? What might be the reason that we couldn't go like petrol engine became more like internal combustion engine?
Electricity supply of electricity production.
Okay, supply of electricity and production. Is that only reason? Maybe supply is not to that extent.
Battery issues.
Battery issues might be, yeah, that's a good thing. We can't say that
Madam,
it's not a
cost.
battery issue.
Yeah.
Yes,
Cost,
sir.
cost of the fossil fuels are very low, very less. Availability is so easy.
Yeah, cost is also a thing, might be, yeah. Actually, what really happened is, since sir was telling about the cost issue, I can tell you, during that period, the petroleum price went down. So because of that, these petrol was cheaper compared to that of electricity. So that was also a reason that we went to the internal combustion engine. That is one thing. Apart from that, there are many other important things also. Can anyone say?
Availability of charging station.
Charging station at that time, yeah, there was no charging station, but people say they don't move very far. Might be the petrol for like petrol stations also might be less only during that time. They charge at their home, wherever they go. At that time also they had these plug-in charging only. When I was reading the article, I could find that the technology has not changed much. And at that time there was lead acid battery. Okay, though technology wise it was not so very advanced, but lead acid battery was there, and they used to charge the lead acid battery and only operate it. Okay, so it is not only that the battery or this. One thing is all those motors which were used at that time. Okay, they were constant speed motors. Okay, for electric vehicle, we require that you have to change the speed. So whenever speed change is required, so induction motor also, it was a constant speed. DC motor was there. With DC motor, speed control was possible, but again, rheostat or like some the component which was used there was more power dissipating. So the kilometers that the vehicle can give was less. So one reason what you can say is the power conversion was difficult because power electronics was not there during that time. In 1884, you can just imagine there was no power electronics. Power electronics mainly came in 1970. Okay, so around 1970, when the thyristor came into picture, and after that, the rectifiers and everything, then this started growing. I'll be showing you a graph where you can see that how is this electric vehicle, though it came before these petrol engines, it was like the growth was not that much, or it was stagnant one. That is because one thing, the cost of petrol was cheaper at that time, it went low, and the other thing is the speed control of these vehicles were very difficult or more lossy. And if you have AC machines there like induction motor and all, if you're using, speed control is difficult. So after 1970s, there was a peak where many research started going on and many vehicles had come. Okay, so this was the thing. And why do we want to go for these electric vehicles? This will be a question even in our mind when we want to get an electric vehicle. One thing we tell about commonly was EVs have a better emission profile than the internal combustion vehicles. If you see a petrol engine, the carbon dioxide emission is 0.2325 that kg per kilometer, and for diesel it is 0.273, and for electric vehicle it is 0.103. So first of all, in order to breathe good air, we require that we have to move to electric vehicle. This is a very important thing. But being an individual, okay, say if I am saying an electric vehicle is around, it's very costly, initial cost is high. Now, if you want also at least 8 lakhs, you should have minimum for going in India to get an electric vehicle. At the same time, within 4 lakhs or a 3 lakh, you can get an equivalent facility based car. So people will surely think, why should I go to this electric vehicle? Is it? That will come in everyone's mind. So why should we go? Can anyone say again that apart from this emission and other things, this is a government may think, or as a good citizen, yeah, to some extent we may have, but still, will you go for electric vehicle, and what will be the reason that you will be going for electric vehicle as an individual if you want to go?
Ma'am,
Yes.
due to environment temperature increase, madam.
Say the environment temperature is increasing, but as an individual, yeah, we have to go, but I don't think so. As a family man, when you think about your budget and other things, you will surely not go for that. Though a good citizen.
Fuel amount is fixed in this world, and after some time the amount of fuel will be so much less that everyone not able to drive petroleum or diesel car.
One is the petroleum is getting extinct. Okay, so in future you're saying there'll be no petroleum, and like electric vehicle is cheaper. Is it that you're saying?
Yes, ma'am.
Yeah, so that is there, but still, say if it is extinct electric, sorry, the petroleum is getting extinct also. I don't think so. I will choose. Like we have to choose it, but many individual will be selfish. They think like, yeah, let it get extinct. Let me use the maximum. Let me go for it maximum. So, is there any other reason?
Low, ma'am. Maintenance cost is low compared to other diesel and petrol engines.
Very good. That's a very good thing. Compared to the internal combustion engine, the maintenance cost is less. Here, if you see, only the motor maintenance is required, and maybe battery also around 10 to 12 years you require a replacement, because around 8 years every company is giving a replacement warranty itself. For 8 years, they say that the battery will be operating in good condition. So maintenance is here very less. That's a very good point. Some other point? As an individual, this maintenance you will see, because every year with an internal combustion engine, I think 4,000 to 5,000 just for service, even for changing the oil, that this you give. Everyone have a car, so you know that. So this reason might be important, because economically you're benefited. You may go. Any other reason? That was a good point. So many people are there. Please come out with your points.
Madam, we can charge that electrical vehicle through renewable energy also,
Yeah.
particularly solar energy, madam. We can set up such type of, in fact, in our department, we have set up an electrical vehicle where 465 watt solar panel is there on its body.
Okay. Okay.
So during the standstill position, it is kept in the south direction. It gets charged and it is being placed at an angle of the latitude of our place. And during the motion type, it is kept horizontal. No doubt
Okay.
charging is less, but somehow it gets charged.
Yeah.
So that is also one of the advantage.
Yeah. But say now if you go to the market, you just think this is all in research stage. Now you want to go to the market and get an electric vehicle. Why will you get it? Now that I don't, in India it is there, only some few auto rickshaws that solar mounted is there. But when you go for a car or a two-wheeler, I just want that as an individual, as a common man. How can we encourage them to get well vehicle? What will be the points which you? One was maintenance, that was very good. Okay, car like
Government
to some extent, I accept that. Yes,
Low operating
and
cost.
government is giving subsidy and for the electric
government is
vehicles
giving
also.
subsidies. Yes, in many cases, government is giving special subsidies in many play for the two wheelers as well as four wheelers. Yeah, that also. Somebody else was also coming with a point. Yes, sir.
Save the fuel cost. Low operating cost of electrical vehicle as
Yes,
compared
that
to
is
fuel
also
based.
good. Compared to petrol, the kilometers, if you see electric vehicle will with less cost, you can go more kilometers. Yes, that's a very important thing. Any other point?
Government is also making policy to remove petroleum and diesel car and vehicles. So
Yes, that is also a very important thing. After scrap policy have come, this
yeah,
is implemented. After 15 years, the internal combustion engine based vehicle, if you're getting a vehicle, after 15 years, you have to scrap it. That's a policy. You cannot do anything. You have to scrap the vehicle. That policy have come. So you just think my vehicle also, I was just thinking around 12 years I have before 12 years I got the vehicle, and that vehicle is in very good condition. Only 50,000, not even 50,000, it's 49 something I have driven till now because I have office and house, not more than that. And you think the vehicle is in good condition. Emission, carbon, like every time we take the pollution, everything is under limit. But now after 2 years or 3 years, I have to scrap it, and you have to give it to the company. Might be they will give a very like less amount as a thing, or maybe I can go for an exchange. So the scrap policy also have come. So you just imagine that being an individual, might be the initial cost is less, I've got the car also, after 15 years I have to give away this vehicle. So that's also an important point, that EV battery requires replacement only in 10 to 12 years. And even companies giving, I told you, 8 years warranty they have already given. Petrol car has a validity of 15 years only. After that, you have to scrap it. So comparatively, if you see, if you get an electric vehicle, only battery you have to change. You need not change the vehicle. That's one advantage. Running cost or the maintenance cost also we were talking about. The running cost also, that also one of the sir said, like the running cost of this vehicle is also less compared to the other vehicle. So let us small do a calculation and see. Let us take that I have an petrol engine. Okay, so petrol engine, and it's approximately 30-liter tank. General vehicles, if you have, it is 30 liters. Okay, so what is the cost of petrol approximately? Is it it's around 100, like 96, 98? Yeah,
102 rupees, madam.
102. But it every, because many states are here, let us take it as 100. In Chandigarh it is around 97, 98 and all, and many states 102, 100 also. So let me take it as 100. Okay, so with this is 30 liters. So for 1 liter, approximately how many kilometers a vehicle can give? With 1 liter,
26.
17.
26, 17. So let me take an average in this case also. Let me take it as 20. Okay, not 26 also and not 17. Let me take it a 20, so that calculation it will be easy. 20 kilometers, it will, sorry, per liter, 20 kilometers into 30 liters. Okay, so this will be the cost per kilometer. It is cost per kilometer. So how much is it? So it is 5 rupees. Okay, it's 5 rupees per kilometer. Okay, might be 8 rupees also it comes. It depends on the vehicle. Some vehicles, like say if you go for a high-end vehicle, it will not give more than 10 kilometers. Okay, so maybe like 4 to, let us keep it as, because somebody said 26 also. So let us keep it as some 4 to 8 rupees. Okay, on an average 4 to 8 rupees it give for per kilometer you have to give. Same thing if I take an electric vehicle, might be how much it will be. So what is the, like, for, let us take a Nissan Leaf, sorry, no, Nissan Leaf, or like, let us take Tata Nexion. So Tata Nexion, do you know what is the battery rating? Anyone? What is the battery rating of the capacity, battery capacity of Nexion? Tata Nexion? Anyone? Or some other vehicle? Is anyone having an electric vehicle? Do you know what is the battery capacity? So here, these are for two-wheelers and four-wheelers, the battery capacity, so declared battery capacity. So let us see for Tata Nexion, how much is it? Mahindra.
40.5.
40.5. Okay, yeah,
AWH.
40.5. Some of the models there. Tata here, three-wheeler, e-rickshaw. Tata Nexion is here. So this is 30.2. Like somebody said 40 because maybe in higher versions it has come. So here Nexion EV, you can see it is 30.2. Okay, 30.2 is the battery capacity. The range it can give is around 200 kilometers. Okay, the company claims around 312 or something, but people, like I read different blogs, and it was given that it depends again whether the person is going on a flat area or whether they are going uphill. When they are going uphill, it gives only 140 kilometers. When they come downhill, it is giving 260, and when it is on a flat it gives 240. But here this thing, they have claimed that it gives around 200 kilometers. This is Tagore. Yeah, here it gives around 200 kilometers, and the energy consumption per kilometer is 0.151. Okay, so 0.151. So this into this 200 will give you how many units it consumes for this 200 kilometers. So it is around 30 units only, because this is 30.2. Okay, so a battery capacity is 30.2 kilowatt hour. Okay, so and this sorry, this is 30.2 kilowatt hour, 30.2 kilowatt hour hai. And it takes, in order to charge this much, in order to fully charge this battery, it takes 30 units, 30.2 units. So you can just multiply this 200 with the energy consumption per kilometer. So accordingly we will get that the energy consumption, the energy consumption also we can get it, and it requires 30 units to fully charge this battery. Okay, so 30 units for 200 kilometers. So now let us do the calculation for this electric vehicle. There it was, we calculated as 5 to 8 rupees. So in this case, for the battery, we know that it is 30.2. So let us keep it as 30. And how many rupees for per unit? For 1 unit, what is the amount approximately in your place?
8, ma'am.
8 rupees. Yeah, mainly it is 8 rupees. Okay. In Chandigarh and all, if you see, it's very cheap. It is 2 to 4. Maximum it goes to 4 or might be 5, not that. But in Punjab area, like in Haryana also, it's 6 to 7. In Punjab, it is almost 8. And maybe in other states also 8 maximum. So let us go for the maximum value, 30 into 8. So it is 30 units are there. So 1 unit is 8. So 30 into 8 divided by almost 200 kilometers. Okay. So it's 8 threes are 24. So 240 divided by 200. So it is approximately some 1.2 or something. Okay. It's 1.2 rupees per kilometer. So we have taken a higher end, but actually if you see it comes to 0.5 to, according to the companies, but it is 0.5, that is 50 pies to 1 rupee. Okay, but our calculation, let us keep it as 2 rupees also, it's not a big issue. But you see that when you use a petrol engine, around for per kilometer, it's coming 5 to 8. And here in this case, it is only 1 rupee. So in long run, when you calculate it for some 6 or 8 years, say for this, they have done this calculation, it takes only 6 to 8 years we spend on vehicle on, so on like on the running cost, or you can say on the fuel, only 1 lakh in electric vehicle. But in a combustion engine, you can see that in a petrol engine, if you see, it was 4.5. Even in diesel, if you go, might be some 3 lakhs or something. Okay, it's not going to change much. So you can see that how much change, so how much difference is there. So maintenance cost is less, the running cost is less, and the scrap policy, if you see, and this is personal level. But apart from that, we have to look into the our society also. So for carbon emission and even pollution, we can reduce, so that automatically our life is also going to increase, because unnecessarily, like we have many other breathing problems also linked with this. So this is why we have to go for electric vehicles. And many researches are possible in this field. One of the thing is, say, in standard load profile, if you see, it's something like this. So this is for 24 hours, 1 day. Okay, and this is for 12 months. So this is in the months of January, February, the load is high. Similarly, in November, December, and all, and in like June, July, the load is less. And this is a profile of Sweden. Okay, and even other countries, if you see, the load profile is something like this only for the for full year. And for 1 day also, if you see, during the early morning hours it is less, and maybe 6 o'clock to 8 it is high, then it goes little low. And after 4 o'clock, when we go home, during that time it is peak. So you can see this area, it is peak. So now in future, if you just think that more electric vehicles are going to be connected, so it's a general thing that once a person goes to work, he may, in office if it is available, okay. Otherwise, once he reaches home, he will put it for charging. So this is already the peak. So automatically what will happen? Again, this peak may increase. This peak may go increase. So that is a problem which many researchers are working with. So load forecasting you can do, and along with this EV, that is also a many people, they are taking the load data already existing, and they are forecasting the load with respect to the temperature, moisture, or the area rainfall, and all these things, and the previous load. So along with that, now this electric vehicle, the load what you are predicting will not be the same, because this electric vehicle growth is more. So now in future we have to take that also into consideration. And many technologies also will come by that time, because here in the evening already the peak is high, and apart from that, this extra demand will also be required. So we can go for technologies where you can off peak it, like during the valley time. So in case, say, if you're having a tariff in such a way that if you're using power beyond some 10 o'clock or 12 o'clock, okay, so people will select, and during this time the charges are high, the tariff is high, and during this time if you're having a less tariff, then automatically people will shift from here into this region. So many research are possible in this area also. And for this also, we had taken a data from Umeo city, where we were trying to see when the people are usually charging. Okay, because in foreign countries, the electric vehicle are already there. So in an area, we could see that when the people are actually charging, that charging patterns can be got in order to do that study. I will be trying to take that on Wednesday morning session, because half an hour I'll be getting there. until our Sweden expert will be connecting. So I'll just show you little more how to do that. Okay, so during that time, so such research are also possible. That these are the researches which are in hand, like where we can make our students work on. Okay, so that's one thing. And vehicle to grid integration, so many research are going on in this area also, like because now we are mainly talking about an standalone system, but in future, if you see, these vehicles will be connected to the grid, and sometimes we may use the grid power to charge it, and sometimes give power back to the grid also. So you have V1G, that is unidirectional power flow from grid to vehicle. That is a general thing which we are talking about. Apart from that, you will have V2G and then G2V. So vehicle to grid, if you see, bidirectional power flow from vehicle to the grid and from grid to the vehicle. And then this technology in foreign countries, this is very common in Netherlands and many other places, vehicle to home. And home to the vehicle also. So if you have, like I'll be showing you a picture, you'll understand it clearly. So this V1G, you can see here, different types of onboard chargers is shown here. On-board or off-board it can be. So there are different types of chargers. It may be level 1 charger. Level 1 charger in Indian system, if you see, it is 3.3 kilowatt charger. Okay, 3.3 kilowatt, and it's 16 amps. Okay, so 230 volts and 16 amps chargers, they are said to be the level 1 chargers. Okay, so that is directly you can plug in the plugs of what we have it in our house. Okay, so, or like you can have specially 16 amp plugs, so that it's an independent one. Otherwise thermal overloading or many other problems may also come. So this is type 1 and level 1, and type 2 chargers are there, or level 2 chargers. They are single phase or 3-phase chargers, and with little higher power, where 16 amps you can go for till 32 amps and even 64 amps, and they charge little more faster. Okay, so many private places, in public places and all, if you see, these level 2 chargers are type 2, you can say type 2 chargers are there. Apart from that, you have level 3, and they are DC chargers, fast chargers. Okay, so these DC fast chargers, many like Chadimo and many other topology based, not topologies, charging standards are there which are used, and these we will be seeing one by one, so you will be understanding that. So these are the different types of chargers. Based on the power level, you can classify them. So from this, again, if you see, like the power which is here is AC, and we have the battery in our vehicle which is DC. So you require a power conversion there. So power electronic devices are used for this purpose. So here you can see, but in case if you are using this DC charger, the output is DC, so directly you will be connecting it, this DC, to this point. This portion will not be available. So based on what type of chargers, this may differ also. Okay, so here you can see when the power is AC, so AC to DC conversion, and then again a DC to DC conversion, that required power, required DC is obtained here. So you have a DC link capacitor, and here for power factor correction, you have a power factor correction circuit here. And after this, you have again a DC to DC converter, because the required voltage level of this battery, accordingly, it will convert this DC to DC. So this is a bidirectional converter. You can take, whenever the motor is running, you can take power from this battery in order to run this, or when the motor is not running, you want to charge it, then, or during running condition also you want to charge the battery. In that case, power will be flowing like this. So it is bidirectional DC to DC converter is used here. Okay, a buck boost converter can be used. Accordingly, the duty cycle can be changed in order to make the power flow on the other direction, or on like in the forward or the reverse direction. So this arrangement is also there. And apart from that, in the vehicle itself, you know, we have the lamps, and you have many other DC load inside the vehicle. You have the stereo system and many other things connected. For that also, based on the load there, maybe a 12 volt or a 24 volt. So accordingly, again, a DC to DC converter is required, and it is unidirectional, because you need to just power the device, power that load. Okay, so that's one thing. And again, if you see here, you use one more converter, That's a traction drive, you can see. That is for just controlling the speed of this motor, and like for mainly for controlling like regenerative braking and other purpose of this electric vehicle. What you have used, you use here a DC to AC in case this motor is an AC motor. Like you use an induction motor or a permanent magnet synchronous machine. In such cases, you go for this AC to DC conversion. But in case if you are using a DC motor here, okay, in that case, this can be a DC to DC converter for the required DC. You just have such a converter here, a DC to DC converter. So again, based on what type of motor we are using and what type of battery we are using, all those things, we will be connecting different converters here. Okay, so like say all the batteries are going to give DC only. So in that case, again, you'll use a DC to DC converter only. But still, in case you want to charge this through a solar also, but some sir was telling in their vehicle laboratory they have used a solar for charging. That technology is also coming mostly in India. The three-wheelers, the auto rickshaws and all, they are now going for this rooftop. Now technology has to advance more, because we also tried here with a vehicle with this solar top, but the problem was the solar panel weight was little heavier, like when you automatically connected the vehicle. So accordingly, the kilometers and everything will reduce. So now we have to go for thin film based solar panels that are there. Even Tesla had tried in their vehicle. So many places this technology is also coming in future. That's really a promising technology. Okay, so in that case, again, you will have here a DC to DC converter where through solar you can charge your battery, and you can even when in this case you can charge from solar. In case solar is not available, then from the grid you can charge it, and then discharge is also required when the motor is running. At that time it will discharge. So accordingly you have to have the control logic for this DC to DC converter. So here you can see lot of research are possible in these power electronic sites. So our students are also working with new topologies for these power converters, where you can go for topologies with reduced number of switches. You can come out with new control logics for these, because the DC bus voltage need to be controlled. You need to control all these converters. So those controls are also very much important. Apart from that, when you are charging the battery, it is not that fully you're going to charge the battery with 16 amps. That is not done. For charging battery also, you have different technologies like CC, CV charging, or you go for different combinations that I'll be showing in my next lecture, where different power electronics have been used, and the real charging of vehicles we have taken data. So that with that you can have an understanding that how the vehicles are charging, what type of CC or CV or what technologies they are using. Different vehicles use different technologies that I'll be showing you. Okay, so CC charging, in the sense, first initially you're charging with constant current, and after that you go into a constant voltage technology in order to charge this. So for that CCCV also, again you have to have this control circuit in such a way that you need to control it. But with simple logic also you can control. I'll be showing you one of the electric vehicle which we have used in NITAR. So what is the circuit? Like, it's a prototype only. So what type of circuit is inside? So this is for unidirectional. Okay. Then V2G, that is vehicle to grid, and grid to vehicle also. So in that case, again, it's the same thing only. So I was just showing you, in case vehicle wants to give it to the grid. So here in this case, it will be a bidirectional power flow should be bidirectional. So the converter what you use here should also be bidirectional converter. Okay, so there you will not be able to use diodes, or sometimes if you are using a power device, you will be anti-parallel connecting diode for making the flow in the other direction, or you have to go for power devices with bidirectional flow. Okay, so you should have bidirectional power flow converters in this place, and accordingly the other things we have already explained. So here you can charge the battery as well as give power to the grid also when you have proper solar power. Okay, so this, and then the vehicle to grid. So this technology is also a very famous one, where you have the same thing, where you can use this solar panel in order, during say daytime, you can just charge this vehicle when the vehicle is not in running condition, or you have put it for in you have put it in the garage, or in the outside in the parking area. During that time you can charge the battery, and during night time when there is no solar power, during night time you can, if you have extra power, you can just try to discharge it. That you can say during the peak hours. Okay, so such things were done in Nissan Leaf, so that I can show you here. So this is Nissan Leaf being used for this V2G technology. This is already being done. V2G is being testing condition in many places. So here you can see Nissan Leaf. Nissan Leaf, this is used for for charging purpose, as well as giving power to the grid. So here it gives a better grid stability. And during daytime, what can be done? The solar power can be used for charging this vehicle. And when the power interruption is there, or when there is no solar power, the vehicle can give power to the grid or the nearby homes. So that is one thing. And during night also, this vehicle can give power to the grid. But just think that during the peak hours, okay, that is during the peak hours. Peak hours is some 6 to 8 or 6 to 9. You can see, you saw that the hour, like it was a peak hour. So when the tariff is very high, so during that time, our vehicle can give power to the grid. And during the off peak hours, after 10 o'clock or 12 o'clock, you can take power from the grid, or like say in that case, from the battery. Like during the off peak hours, you can charge the battery of this vehicle from the grid, because the power during that time, the cost will be less. So such things is already being tested in Nissan Leaf, and it was used in many emergency conditions also. So you can see here Fermata Energy in Danville in Virginia is experimenting this V2G technology with Nissan Leaf. Okay, and apart from that, Tohoku earthquake, typhoon, facts like during the during Tohoku earthquake and during the typhoon, Paxi, and then during the nuclear disaster in Fukushima, the Nissan Leaf was used in Japan for powering energy, for giving energy. And apart from that, in United Kingdom, also UK, many of the drivers were given these Nissan Leaf. They could earn around $1,200 per year when they were just standing in the taxi stand, because they started giving power to the grid. So this technology has come, and now maybe in future, when all these taxis are converted into these electric vehicles, then the grid stability can also be made better using these electric vehicles. So such research are also in going on. So if you are interested, you can go look into such things. Okay, so coming to the vehicles and the different battery systems we are using in electric vehicle nowadays. If you see, you can see that some of the batteries which are used are lead acid based batteries nowadays. Yeah, we are going to lithium ion. Even sodium based and nickel based batteries are better, but they are little costlier. Okay, so nowadays mainly we are looking into this lithium based batteries, which is growing very faster. And batteries include the sodium based batteries. They are such as sodium chloride and sodium sulfate based batteries are there. Then nickel based batteries and nickel ion alkaline and nickel metal hydride and nickel cadmium based batteries are also available. And lithium, again lithium ion, lithium polymer based batteries are available. And next, if you see, these batteries are there. Say you have some AC system where like our power, AC power, then you use a converter here, AC to DC, and you're charging the battery. Okay, so here this battery always the output is DC. So now you can see in the vehicle the machine, like the motors, if you see, or the electric machine, here there are different types. You can have DC machine, you can have induction machine, permanent magnet synchronous machine, switch reluctant machine, or the synchronous machine here. Okay, synchronous motor. So these are the different possibilities. So based on whether you want DC, in this case you will go for a DC to DC converter. In case if it is AC motor, then you have to go for a DC to here, like AC to DC converter. Okay, so it's a AC to DC converter. Here it is a DC to DC converter. They say again here you have AC, like permanent magnet synchronous machine. So again you require AC to DC. Similarly, you will be going for all the machines, whichever type of machine we are using, we go for this DC to DC or DC to AC conversion. So here again DC to DC conversion, and here again a synchronous machine AC to DC conversion. So this is the main thing. So now our main thing is the power electronics. What you are using here is also a very important issue. Like it should be more efficient power conversion without any losses, and this power like what you can say, without losing much power, the power has to be transferred from this low, like the source end to the load end. So that's a very important thing here in this case. Okay, so next is the electric machinery technologies in electric vehicles and HEVs from 1884 to 2016. So you can see here, I was telling you about the DC machine, induction machine, permanent magnet synchronous machine, switch reluctant machine. You can see here during this like 1900 till this point, like 1970s, it's almost constant. So that is a time when internal combustion engines were more prominent, or like because the fuel cost was less and people were using it. After this power electronics came, you can see that there was some increase. Okay, so mainly these DC machines, DC motors were mainly used in many of the electric vehicles, and after that this permanent magnet synchronous machine came, where drastically it is increasing. But in Indian scenario, if you see, many people are working with this induction machine, because like here permanent magnet, if you see, we are dependent on China. So again, the cost of the vehicle and everything will be interdependent. So many research, more IITians and many of the companies, they are trying to work on these. Even you can see the ABB expert, he has given with this induction machine only. And many like research papers, if we see, they are in Indian papers, if you see, we are moving towards these induction machine in order to get a characteristics which is similar to these. Okay, and mainly you can see around 64% it is permanent magnet synchronous machine. Then you have the induction machine 17%, and even DC machine 18%. So now we are mainly moving towards the other machine, though the permanent magnet synchronous machine has a very good characteristics for these electric vehicles. Then coming to the storage technology, you can see that, say, one thing which is very much important is you can use these batteries, fuel cells, or capacitors for these charging purpose, like for as a storage unit. But when you take a vehicle, that vehicle, how many people you can carry and how long you want to go, it depends on something called the energy density. Okay, so for carrying more people, or you can see here somewhere here, from how far and how many passengers, for more people and how much distance you want to travel, the energy density is very much important. Okay, the energy density is important during that time, for how far you want to go and how many passengers. So energy density is high in case of fuel cell. They are under, like you can say, study only, because cost wise it is very high. So mainly we go for batteries. So batteries have high energy density. And the other thing is, in case during starting and during the climbing position, or regenerative braking position, or you want to climb up the hill, in such condition, or when you're starting after the signal, you're starting the vehicle, during that time you require high power density. Okay, so like battery, if you see, they have a low power density, okay, but high energy density. So nowadays, lot of research are going with the combination of this. So that can also be an area of research where you can go for battery and supercapacitor combinations, where you're first of all looking into, and when it is a normal road, it can run with the battery capacity itself, and suddenly now you want to go uphill, or you have stopped in a traffic and again you're starting it. In such case, you can have supercapacitor or ultra capacitors which can give power to these batteries. Okay, one second. Am I connected, or let me see, because these calls are coming mostly when. Yeah, now anyway, it is 11:07. We will start now. We can take a short break. We will continue with this lecture till one we have. We will be continuing. My lecture only will be going there. I'll be taking you into many power quality issues and many basics of these electric vehicles. Okay. So now you can take a short break, and sharp 11:35. Okay, 30 minutes break you can have. You can go have your tea and other stuff, and you can sharp come at 11:35. So now it is 11:07, 11:35. We will be starting with the lecture. So participants, you can take a short break and come back at 11:35. So don't leave the thing, you be connected. Okay, so don't leave it, you be connected. And because we'll be, and for the participants at knitter, you will be getting a Google form also. You have to mark the attendance in that. Apart from that, your login details also we are taking. So how long you have your online, based on that and your other attendance, we will be marking your original attendance. So for the knitter participants, those are not getting the Google link for marking the attendance, you can just mail me. Okay, so accordingly, I'll be telling Gopal, who's he's assisting me in this thing. So he's the co-coordinator of this course. So I will be asking him to send you the Google link for all the participants at Knitter Center. And other centers, you will be giving your attendance to your coordinator. Okay. Kiran Kumar sir, you can mute yourself. We'll take a short break and we will be coming back. So a very good afternoon once again. Let us continue with the lecture. Let me share my screen. Good afternoon, sir. So Selva Kumar sir, have you joined? You didn't get the link and now I've sent it. Are you there? Some participants had some problem and I had sent the link again to them. So have you joined? I think Selva Kumar sir is there.
Yes, ma'am. Good afternoon.
Okay, yeah. So sir has also joined. Okay. Okay, sir. You're from here. Like Selva Kumar sir is from Himalaya College, Chennai, is it? Sorry, Hindustan College, Chennai.
Yes, ma'am.
Ah, okay, okay. So you're there. Okay. We will be like we are recording the thing, so you need not worry. The first session also we will be sending it to you. Okay, sir.
Sure, ma'am. Thank you, ma'am. Thank you.
Okay. And charger, why we go for this is a DC charger which is very fast charger. So which company, like say which manufacturer you are getting, they may give you an charger, and mostly those chargers, if you see nowadays when you get these charging stations are very limited. So as a customer, what I want to connect in my home with a 3.3 kilowatt charger. Okay, or sometimes if you have a 7.6 kilowatt charger, you can install at your home with 32, then they will make that arrangement for you. Okay, so mostly the chargers with the company which is coming, that only we go for, and most probably it is a type 2 charger, because in Europe as well as in India, this is more prominently used. And Chadimo charger, if the Chadimo chargers are the fast chargers. And like say in our mobile also, you may have sometimes a type C itself, type C charger, or some other mobiles, they have different. But the advantage is you have adapters there, like with different charging ports. So even if your vehicle have a particular type of charger, with some adapters, you can charge in different other thing. It is not that only with this charger. Say if you have a charging station, you have the provision that might be it is yours is a type 2 charger, but with some extension or with some adapters, you can even charge in the other. Okay, so there are facilities. It is just like our mobile. We like say if we want to connect in a particular, you have multiple chargers connected, whichever you want to connect, you connect it. Is it the same way here also? But there are some standards, and mostly this is the thing. And as you said, why do we go for the CCS charger? Is CCS charger is a combination of AC as well as DC charger. Okay, so that's why most probably we say that, like you're saying about a Chadimo charger, that is a DC charger. So this CCS is a combination of both. You have two types of CCS with this type 2. So CCS is a combination charger. That is what is CCS. So you have the DC, you have this DC as well as this combination type 2. So this is CCS2 charger we say, which has this combination. Or say you have CCS, this one, which is a single phase, like so that in our houses and all, when it is single phase, you go with the line and neutral with this option, with this option, like with this communication port and the DC. Okay, so DC is fast charging. For DC is mainly for fast charging. So I will be showing you some measurements where I can show you that the measurement what we did was for a DC fast charger. Okay, it was an ABB based fast charger, but different vehicles, even slow charging vehicles, had come and charged there. So you require only like what to say, connecting like connectors there which are compatible to be connected to any charger. So now even companies, they give like similar to our mobiles, we have different charging ports, but mostly commonly there are some standards. We will not be able to go out of it. Okay, so most commonly this type 2 charger is used in Europe and India and all. This is very common. You can find in all charging stations also. And as you said, this CCS charger along with this combination will be better with a DC and a AC charger. Okay, Chadimo chargers also, this is a Japanese charger. So that is also a DC charger with power which is greater than 50 kilowatt. But when you see in Indian system, we don't have that much high, because technology wise also, like now we are like these DC chargers, if you see the Bharat chargers and all, you can see it is 15 kilowatt, and even higher rating we have Bharat DC chargers. In India, we are promoting that we should go for our own chargers, but they are also like it's a similar thing only. You have the AC for 10 kilowatt, as well as this is the Bharat AC charger, and similarly DC charger, this is fast chargers with 15 kilowatt, and I will be showing you some other ratings are also available. Okay, so is my question cleared there, sir? The one who asked, I couldn't see.
Yes, madam. Yes.
So that, like say, throughout the world, we have some standards. If you don't want, why we go for Chadimo chargers? Chadimo chargers can charge within 20 minutes. Okay. But in India, like say, such fast charging, again, your capability, say, when you're charging in 20 minutes, you have to take 100 amps or 200 amps from the grid. So your grid should also be having that capability. So now it is like infrastructure also should be improved. So that's why even the Ministry of Power is telling that when you're connecting such chargers, you have to see that the separate transformers are given for it, and it has to be done. So now people are also getting vehicles now only, so that infrastructure and everything will be developed. But for now, the best one which we can say is this type 2 charger, which is also fast. Maybe within 1.5 to 2 hours you can charge your vehicle, because it is 32 amps charger mostly, and even 64 chargers are available, type 2 chargers. So we go for this one. But might be in future more like the Chadimo is also available with some of the companies. I'll be showing which are the companies which are providing. So when you get those vehicles, they will automatically give this. But it is not that when you got that charger, you can only charge with that. You can go for different ports. Okay. And then say when you're doing some testing of these components also, we have to take care that NABL accredited laboratory, you have to test it. And this is the standard for plugs. So as sir was also asking, this IEC 60309. So when you're going for interviews, you're interested in this. This also is a very common question. They ask what standards for these plugs and sockets, and you can see that these plugs and maximum voltage allowed is like 1000 volts DC or AC, 800 amps and 500 hertz, and with the color of that charging port. So many a times you can see that where they are like say blue colored or some white color. Based on that itself, you can see what type of charger is that. So it is say 40 to 50 volt charger, single phase AC DC power, then in that case it is a white color. And if it is yellow color charger, then 100 to 130 volt. It is according to the standard. So the chargers have based on that color, these chargers are classified. And say 120 to 250 volt, it is orange color, and it is series 2 current rating charger, and you have the blue color chargers also. So you can see these are the different according to the standard. Okay, so next is Bharat, the DC charging specification. As I already told you, I was telling like we had shown there a 15 kilowatt charger, but apart from that, for DC, even 30 kilowatt and 50 kilowatt chargers of Bharat DC are available, which are little more faster. Okay, as you go for higher power, more current will be drawn and faster you can charge. So 48 volt, 72 volt are based vehicles are available. Mainly the Mahindra E2O plus P8, Mahindra E Verito. Then upcoming Tata cars also use this voltage level, and up to 750 volts batteries are charging capabilities are available, and mostly the 750 volt is in Nissan Leaf and many of the global vehicles, they go till 750 volt. Okay, so like such arrangements are also available. So 11.1 DC charger is up till 200 amps, and this is the voltage level, and this is the power level. 10 kilowatt and 15 kilowatt is level 1 DC charger. And then if you go till 1000 volt, it is 30 kilowatt and 150 kilowatt. It is type level 2 DC charger. Okay, and some of the DC plug connectors. So these are the DC plug connectors. Very common model is this Chadimo. Chadimo in Japanese means chai pilo, something like that. You take a tea. Okay, so in the sense when you drink tea, 15 to 20 minutes you can drink, and by that time your battery will be charged. So mostly the Nissan Leaf and some of the like companies like Mitsubishi, they go for this Chadimo. And you have SAS, that is this combo charging system, CS. Mainly it is available both for DC and AC charging. Okay, so BMW, GM, Volkswagen and other car makers, they go for this. And superchargers, Tesla has their own charger. Okay, superchargers. And Tesla use Tesla is using this superchargers, and GB by T is also a charger. Mostly Chinese companies like Chinese companies as well as Mahindra, Tata electric cars, which are to be coming to the market also. They mostly use this GB by T chargers. Okay, so these are some of the standard these manufacturers give, but it is not limited to that. If you have connecting connectors, you can connect it to any type of charger. So this is a DC plug connectors, that is CHAdeMO connectors, and this is CCS. You can see there in CCS you have a AC port as well as this DC port, and this is GB by T connector, which is also similar to this is a DC charger. Okay, and next is this Bharat AC charging specification. So normal AC charger, if you see it is 3.3 kilowatt or 2.5 kilowatt, you can see here in Indian system, 2.5 kilowatt and 3 kilowatt chargers. Okay, and it is used both in all two-wheelers, three-wheelers and four-wheeler. And in AC also fast chargers are available, that is 7.7 kilowatt and 22 kilowatt. Here I think it's 32 amps and this is 64 amps. Okay, so for such charging, you go for this fast chargers, and mostly Nissan Leaf, Tesla and all have their onboard chargers or fast chargers. So these are some of the things. So most common thing is this one, type 2 charger. This is according to IEC 62196. This is used, and it is used in India also. Connectors most commonly used by this global EV vehicles like Mahindra also, then Nissan Leaf, Renault, all these things use this type 2 chargers. In scooters, you can see a normal plug which we use in our houses. So such plugs can be used, okay, with 16 amps. And this IEC 60309 sockets are used by e-rickshaws, and again Mahindra E20 and Mahindra. So you can see that the Mahindra is using both chargers. So it is a universal charger only, like you can say with connectors, you can connect with any of these chargers. Next is the companies which are selling AC chargers. Many things in the market, mainly Bosch, ABB, all these things are having their chargers. Apart from that, in Mumbai, Mass Tech Control, they are and similarly in Bangalore, a startup with Drive Amps. Similarly, Exicom in Gurgaon, all these are also manufacturing their chargers, and they are in the market. Okay, so these are some of the charging manufacturing companies of chargers, and these things, the battery terminology, say state of charge and all these things, I'm just skipping it because of time. Tomorrow we have a session for this battery management itself, so they will be giving you more insight on that. So now let me just show you a EV charging station. For charging the battery, we have tried to develop our own charging station. So mainly if you want to charge the EV, there are different things. One thing is charge the battery, and battery swapping can be done. Apart from that, PV standalone system or PV grid connected systems can also be used, or directly from the grid also you can charge. So these are the different approaches available. Okay, so in that case, when you want to charge it from the grid as well as the PV, the connection is something like this. You have the solar, you have a DC to DC converter, and similarly from the grid, AC to DC conversion. Okay, and then that DC, what you get, again using a DC to DC converter, you can charge the battery. And so you have a central control unit which will be taking the voltage current at the different places, and accordingly it will control these converters. So this is the logic. So first of all, we did the simulation in MATLAB, and then we went for a prototyping. So here you can see in this system, solar was used. Okay, the current sensor and voltage sensor, the data is taken to the controller. Similarly, here you require DC for charging the battery. So here a DC to DC converter is used. Okay, so DC to DC converter. And when solar power is there, this red wire is connected. Okay, and accordingly the battery is charged when solar power is there. So a control logic will turn on the relay, the DP/DT switch into this side, A and A dash. But when solar power is not there, automatically from grid we are going to take the supply and we will connect it. So here, in order to avoid one more DC to DC converter, okay, we had put here a relay. So a little more simpler connection. So here you can see from the grid, you are rectified. Okay, So here AC to DC conversion, and then again DC to DC conversion, and we are connecting it to the BB port. So accordingly, this will be in this location when solar is not giving power. Okay, so in this case also the voltage is being sensed, and accordingly, according to the voltage and current, this and this voltage, the controller takes the decision. So this is the control logic which we had used here. So MPPT was also like for maximum power point tracking, the voltage and current was taken at each instant. Voltage and current was taken, and in that case we again we changed the duty cycle of the DC to DC converter in such a way that this power is going up, and if in case if it is coming down, the duty cycle was changed in the reverse direction in order to make it go up, and this point the solar panel was made to operate. Okay, so MPPT, different algorithms can be used here. Initially, since it was a simple thing, perturb and absorb algorithm was used. In that case, first of all, a MATLAB simulation was done. Like you can see here, a DC to DC converter, and this is the EV battery, and this is the solar. So it's a very simple model. Even in like MATLAB file exchange or in MATLAB also, you can take different components, DC to DC converters, and this battery is available. You have PV, you can interconnect it, and you can form this. Okay, so first this was done by Arshdeep, one of my students, and like without MPPT and with MPPT, he had tested and he got the output here. With MPPT, you can see it has tracked a better power. So then for the battery, we had used, this is the original circuit which we'll be seeing step by step. For charging the battery, here since it was a prototype, we took battery from our laptop only. So it was 6 lithium ion batteries of 4.2 volt each. So it was connected in such a way that we get a voltage of 24.2 volts. So series may you have connected, so you get 24.2 volt battery there. Okay, so like, and it was around say 3200 milliampere hour battery only. So it's like there the current initially, if you see, it will be very small current only will be taken. So you can just generally say that if it is at say 20 ampere hour battery, okay, you have a battery of 20 ampere hour. If you're charging the battery at 1 amp rate, so it takes 20 hours to charge this battery fully. So same 20 ampere battery, if you charge at 20 amps rate, okay, you're charging at 20 amps, you're drawing 20 amps per hour. In that case, within 1 hour, you can charge that battery. So the logic is like that. So here, now we have to have circuit, whether we have to see whether we want to charge at a constant current or whether a constant voltage, and based on that logic, then we will be charging it. So here, until 17 volts was reached, we charged at 0.1 C. Okay, and the current was 0.1 C. After 17 volts until this 24, again it was CC only, but 0.5 C. Okay, and once it reached 24 volts, it went into constant voltage charging. Okay, it was, the voltage was maintained. So at that time, current was fallen, and this CV charging was done. So for this, the circuits were also used. I can just show you. So this was the overall circuit of the prototype which was done. So this was from the grid charging. So grid, battery, rectification, and here a boost converter was used. So after rectification, the DC what we got, it was again boosted. DC was boosted, and this was used for charging the solar power. So one solar panel is there for charging. In case, I'm very sorry, for charging the battery. Grid power was used for charging the battery here. So battery terminals can be shown here. So when solar power is not there, when no solar power is there, grid was used for charging this batteries. And while charging, there are two logics. One is the constant current and another one is constant voltage. So actually it will just measure the voltage of the battery before, until the 17 volts are reached, it will be in constant current mode in 0.1 amps. it draws only 0.1. So yeah, accordingly changing the resistance value here, it will be getting only 0.1 amps. After this 17 volts until 24 volts, again this resistance is changed in such a way that it draws 0.5 amps. So charging will be occurring at 0.5 amps. And once it reaches 24 volts, then this circuit will be removed and like it switched off. The relays will switch it off from this into this constant voltage charging. And after that, it goes in the constant voltage stage. So CC-CV charging is done using these two circuits here. This circuit and this circuit was used for CC and CV charging. And when solar power is there, okay, so here you are just measuring the voltage, current, and all those parameters are measured, and it is an Arduino Uno was used for this. So here the solar voltage and current was also measured. So in case solar is there, like if solar power is available, then again a boost converter is used here, and that voltage is boosted, and the relay also will get turned on into the solar side, and the CCCV is done by this solar. If solar power is not there, in case solar is not there, it will get switched on to the other. So an indicator is there in order to determine whether it is solar or is it from the grid. Okay, so this was a circuit used. It was a very simple circuit. And for determining the state of charge, like how much the battery has charged, an LM3914 IC was used, and which has all these pins. So based on this, like here LEDs were connected. So based on that, how much the battery has charged, automatically the state of charge can be obtained. But this is not a very good method, but say for prototyping in the initial first stage, we want to know how much the battery is charged. We had gone for it, but when you are going for like a real vehicle, they go for more accurate methods for determining the state of charge. Okay, so this was the first prototyping which was done, solar panel. When we covered the solar panel fully, then power was taken from the grid. So this is the grid turned on when solar is not working. When you fully cover it, automatically it goes to grid. And when solar power is there, it works in the solar. And this was the indicator, like the state of charge indicator. So this circuit here, you can see that is this one, just to determine the state of charge. Okay, and Arduino Uno was used for the firing and other things. So PV grid charger, this is a PV, like when solar is there, from solar it was charging, and when solar power is not there, from grid. And simply in order to discharge this battery and charge this battery, like here electric vehicle DC motor was used in order to discharge it. So same thing, it was given to next student who had converted this DC to DC converter in the solar side with an interleave boost converter. Okay, and this circuit, their current ripple, which was due to this buck converter before, was also reduced. So, and after that, the voltage at the voltage level output was also increased, so that we can use it in a real vehicle. So that's why this interleave boost converter was designed. And that was then afterwards, this was the interleave boost converter, and its voltage, output voltage current, output voltage to input voltage was given by V naught is equal to V in into 1 plus N. N is the number of this channels here, like a number of coupled you can say the directly coupled, that interleave boost converters module. So how many modules you are connecting? It's said to be a diode capacitor multiplier, you can say. So when the number of multipliers increases, automatically the N value also increases here. Okay, so this is the duty cycle. So this interleave boost converter was also being designed, and after that it was implemented in a small electric car, you can say the toy car. Okay, and our students were sitting on this and they were testing it also. So this gave a better. So the same model was then we used this vehicle. He will be like Ajay will be explaining you, but this whole vehicle was developed by them. But we use the charging, only the charge for the charging purpose. We use the solar based charging, and we tested the circuit which I showed you before in this vehicle also for charging this battery. Here it was lead acid battery. There when we did the prototype, it was lithium ion. But because of the cost and other things, here the already existing batteries they were using. So that's why here lead acid batteries was used. But same technology can be used for the lead acid, the lithium ion also. So this was a thing which actually gave me an opportunity to work in the electromobility team in Sweden also. So there was mainly the power quality side. So that I'll be discussing now. Some of the futures of, yeah, we can just go through this also. What are the different in future? What are the different advancements? One is the light detection ranging. That sensor will give autonomous car second sight beyond the cameras and the radar provide and the radar provide. And the LiDARs use laser diodes in order to measure the distance between the objects surrounding the sensor. And this is mostly installed on the roof of the car. Okay, so this is also a technology which is coming. Another one is the inductive charging system. So many of the vehicles, they are going for the, say, the BMW. Many vehicles, they have these chargers, and on-road chargers are also there where the whole road is the charger and you have to just drive over it. So this is a standstill. You have to go and park the vehicle over it. So many technologies are developing in this area also. Okay, in-hub, in-wheel motors. So that is also a technology where like intelligent in-wheel motors are there, which can be used for propelling these vehicles. Then many researches are going on. One is the gallium nitride inverters. So they are like high volt. They can operate at high voltage, high temperature with high switching frequency with a better efficiency, okay, than the silicon version today. So that is one of the advancement. Then power electronics also, many converter topologies can be used, and with reduced number of switch so that the weight can be reduced, and many advancement is there in that field. Lithium ion batteries are also being nowadays used for this storage. So many researchers are going in that. Ultra capacitors and super capacitors that I was telling you, that for higher power density than with the, along with the energy density if you want, then you go for the combination of battery and these ultra capacitors or super capacitors. Then carbon polymer composites are used for the panel. So many times panels are also in future you can be installing over the roof. So there the weight should be less, and many researches are required in that field. So here carbon polymer composites are used for these panels. Then processors will turn to tomorrow's car into a rolling supercomputer. So in future, if you see you want to charge the car, you want to discharge the car to the grid, like you want to give power to the grid. So there processors also play a very important thing. They are the intelligent computers there. So many researches are going on in IoT based such processors where you can get data and process it. Super light metals in the chassis that further eases the load on the propulsion system. So super light metals are also there. So these are some of the things, and now let me just take you to the other lecture where we will see the power quality side. Okay, so these are some of the researches which I did in Sweden. I can say the power quality issues due to EV integration with the grid. So when an EV is integrated to the grid, lot of issues are coming, power quality issues are coming. So what might be the reason? Because when an electric vehicle is connected, you can say that a large amount of current is being drawn by the grid. So this results in large power quality issues. Let us simply take a simple example and see. Let us first imagine that our vehicle, the vehicle we have, okay, the vehicle we have as a motor, and that motor is using, let us think that the motor which is having some 5 kilowatt, we are using a 5 kilowatt motor, and this 5 kilowatt motor on an average a day, let us say that 5 hours it has to travel. So how much energy is required? You can say that it requires around 25,000 watt hour. Okay, 5 kilowatt into this 5 hours, so it is almost 25 kilowatt hour energy is required. Okay, so let us consider that the battery system here in this vehicle is having a 300-volt battery system. Okay, so in that case, this 25,000 divided by 300 is approximately some 83.33 ampere hour. Okay, so approximately to run this vehicle, you require an 100 ampere hour battery. Okay, when you want to run this for 5 hours, at least 100. So we came to a conclusion that 100 ampere hour battery is required for us to run this vehicle for some 5 hours. Okay. So now you just think you want to charge this 100 ampere hour battery. Mostly 100, 120 ampere hour or in that range it is used. So now you just think you want to charge this battery. So how long will it take to charge this battery? Can anyone say? Let us take, you want to charge it with 1 amps at a rate of 1 amps. How many hours will it take?
It will take 100 hours.
It will take 100 hours. So it is not possible that we are just waiting for a long time to charge. And in case if you are charging at around 100 amps, it will take 1 hour.
1 hour.
1 hour. Within 1 hour, you can charge if you are charging at 100 amps. Just imagine you're taking 100 amps from the grid to charge it faster because everyone want to charge, and nowadays the technology has also come. So within 1 hour you want to charge, or you want to charge within 2 hours. That is also okay. Then 50 amps you have to charge at a rate of 50 amps. Okay. So similarly, you just think that taking 50 amps is also a very great amount. This is only for one vehicle I am telling. But if there are some 100 vehicles, in future, if you see more number of vehicles will be there, and you just think all these vehicles are drawing large amount of power from the grid, what will happen? So large amount of power is taken, and here you think lot of power electronics are also connected. So you can just think what type of power quality issues it can bring to the grid. So that's a very major issue. I'll be showing you some measurements of what we have taken. We have taken 160 kilowatt charger. We have taken some measurements, which I will be showing you. So what are the other problems that can come in this? One is when the electric vehicle is charging, in foreign countries, they have found that the garage, the lamp starts blinking. So this was one of the issue which was seen. So what was the reason? I'll be showing you in the future slides. Okay. So when the electric vehicle is charging, it is bringing some issues into the local, like in the distribution side itself, it is bringing some issues. That's one problem. Another thing is we were now all talking about the cars. Just imagine that when large buses are there. So this was the area where I was staying in. So I just took a photo when the electric vehicle was charging. This is a pentagram where the thing just comes down, gets connected to the bus, and it starts charging. Okay, and these are all the houses. These are the houses which are connected, like which are in that area, and you can see that this vehicle is also connected to the. This is a Here you can see a small house here. This is said to be a transformer house. They keep all the transformers inside a house. So this is the transformer house, and this transformer you can see is providing power to this charger as well as these houses. Okay, so when this is a bus, in car only we were talking about. So in buses and all, within the technology has come that within 5 minutes they get charged, or 10 minutes, not more than that. They have to, because it's a stop. When they stop, they have to charge. By the time the person get inside, it has to charge, and then it goes. And here you can see the ABB converters there. Okay, the ABB converters were there, which was powering this pentagram for charging this bus. So you can see that when electric vehicle, like when buses are charging or when trucks are charging, It draws more current than these cars. So that is also a very big challenge which has to be addressed. Another challenge which is we were all talking about solar panels. So here this is the Kochi airport, you can see, which is 100% solar powered. Okay, and now this the parking slots are the shades are used for the parking slots, but in future when electric vehicle comes, the electric vehicle chargers will also be here. Okay, and that vehicles will start charging from these chargers. So one more problem here is like Horseman from Netherlands. He did a research. He did a research in a Tempo factory, that is a paper mill, and there he had around 3 solar panels, so like solar plants of 250 kilowatt, okay, and around 315 amps current rating. He had 3 solar plants and around 10 EV charging stations. So he had 10 EV charging stations, and he could see that during the measurements, he could see that during the afternoon hours when solar was giving maximum power from around 12 o'clock to 2 o'clock, and when EV was also charging, some of the harmonics based on what type of converters are connected. It was a 12 pulse converter, so he could see that the 11th harmonic and the 13th harmonic, because it's a 12, mostly the 11 and the 13 harmonic will go higher. If it's a 6 pulse converter, the 5th and the 7th harmonic will go high. So there it was he could find that the 11th and 13th harmonics are going jumping. The term what he has written in this paper is it was continuously seen jumping, and it was varying with very great amount, and the magnitude was also high. So there is a correlation that when solar and this EV is charging, there is possibility that like the interaction of these harmonics, the harmonics generated due to the power electronics of these chargers and the power electronics of these EV and the PV, and PV also, the harmonics goes on varying based on the power level. Maybe during the morning hours when the power is very less, and then the power, like in case of a PV charger, the PV, if you see the power is something like this. During the afternoon hours, the power is maximum, and during the daytime, the power is during day and night, the power is less. So the harmonic level also will be high during this daytime when maximum power it is generating. And during that time, when we are in the office, we want to charge, this will be a great issue. So we know that future is with solar and EV, but this combination, lot of research is possible. So if anyone is interested, you can start measuring and you can just check whether how these harmonics are varying. Many papers are also there in this. Another big issue, what we have seen, like in places which are cold, say in northern part of India also, the climate goes, in our area, it goes till 0. Maybe in Jammu and Kashmir and other places, it goes till -30. Even this is not the problem. Like in that case, battery is an issue. Battery gets discharged faster. It is not only the problem in Jammu and Kashmir, even in the south, when the temperature goes above 40 degrees. Okay, the same characteristics of -30 is seen there also. It's something like a U, which draws more power. So when you're charging the vehicle, more power is required. Like you can't say, like say a battery is there, only the same amount of power is required, but you need to charge more times in winters and in extreme summers compared to the other time. So during winters and extreme summers, the loading of transformers will be higher compared to the other time. So such research are also possible in these electric vehicles. So lot of power quality issues, even many in the group where I was working on voltage dips and voltage sags, many such researches are also done. I'll be sharing you the reports where different type power quality studies have been done. I have just picked up some and I'm just showing it here. Okay, so this is one of the issues on power quality. And we were all talking about the chargers. So the chargers are level 1 chargers, level 2 chargers, and level 3. The level 3 chargers are the CHAdeMO chargers. Okay, so you can see here, this is the CHAdeMO charger. That like level 3 DC charger. So this combination charger, this DC also comes, and even Tesla have their supercharger, which is also a DC fast charger. Okay, level 2 chargers. This is the type 2 charger, which is common most in Europe, in US, and in India also. We go for this charger, and here, if you see, it takes around 22 minutes for charging. In level 3 charger, again within 10 minutes you can charge. And in level 1 charger in India also, we go for this type of charger. It takes around 5 to 7 hours, or even if it is only completely BEV, this is plug-in hybrid electric vehicle. If it is completely BEV, then it takes around 17 hours for fully charging the vehicle. More clearly in Indian, according to the Indian standard, if you want to say, this will be a better thing. Single phase 3.3 kilowatt charger with 16 amps and 230, that is single phase. So in that case, it takes 5 to 6 hours. Same single phase with 230, but 32 amps, 7.4 kilowatt, it can charge in half of this, that is 2 to 2.5 hours we can charge. When we go for three-phase chargers like 11 kilowatt, 22 kilowatt, or 43 kilowatt chargers are available. According to the power increasing, here it is three-phase only, so 400 volt, but 16 amps, 32 amps, or 63 amps. So if it is 16 amps, 1.5 to 2 hours for charging, 32 amps, 44 minutes to 50 minutes, and if it is 63, it is 22 minutes. So that's why these chargers are somewhat equivalent to this DC charger, though DC are still faster. We can say that, this is also almost 20 minutes charging, and this is also 20 minute charging. So DC chargers, the Chadimo chargers or the CCS chargers are little faster. Say here you can say 100 to 125 amps charging current it takes. Okay, and it is a 50 kilowatt charger. And 120 kilowatt charger, it takes a very maximum current like 300 to 350 amps charging, and can charge within 10 minutes. So what we did is in Sweden, when I was there, we went and did a measurement in a place called Tintorp, which is in the northern part of Sweden, with very extreme climate, around -30, when with full snow. At that time, we went for measuring it, because for extreme winter testing, all the companies, like all manufacturers of vehicle, they bring them there and do all tough testings in that condition. In India, it is done in ICAT. They have an atmosphere being built up in such a way, and they are doing it. But in Sweden, since that atmosphere is already there, they come for there. So during that time, what we did is we went and did the measurement. There were 8 ABB chargers and 8 Fuji chargers, but we did it in the ABB charger there. So these were the chargers, like say similarly 8 chargers were there where vehicles were charging at the PCC, the point of common coupling. At that point, we connected a power quality analyzer. It was a Yoki power quality analyzer. We took the data and then we pre-processed the data to analyze how is this charging actually occurring. Okay. So if you don't have such chargers, or like if you are in an institute where you want to like don't have those charging facilities, then hardware and loop system is also a possibility. One case, if you don't have this also, then you have to go for simulation based models only. But in hardware based simulations, what you can do is the grid simulations can be put into the simulator HIL. Okay, and the device under test, you want to test a power electronic converter, or you want to test the battery system, or whatever system you want to test, that test device under test can be kept here. Using sensors, the low voltage thing can be given as input to this HIL, and through power amplifiers, the low power can be converted into high power and connected to these test devices. So this is also a possibility of research. Next time also, we will be trying to contact with some of the manufacturers like Opel RT, Typhoonil, to have dedicated course on these, where that will be a contact mode course where you can come to NITTER and learn these technologies. And if you have some research going on at your end, you have done some simulations for testing also, during that time, if you come, those engineers also will be there. They can help you out. So we will be planning for these courses in the upcoming O-plan, the next year O-plan, because now like we have started with contact mode courses also. So what are the limitations that these electric vehicles can bring on the grid? Many research are going on in this end. So you can also start looking into if you are interested. So first of all is when the electric vehicle is connected, it may bring under voltage. What are the conditions? Say, let us take that you have an RYB phase and a neutral, and you're collecting the electric vehicle. So at your home, so if it is a single phase, in that case, you will be connecting it in this thing. So this is an AC, so AC to DC conversion, again a DC to DC converter, and then you will be connecting it to the battery of your vehicle. So this is your vehicle, okay? Or maybe if it is an on-board or off-board, all these charges you have to see. So accordingly, you will have a battery. So this is your vehicle, which need to charge. So this vehicle is the load here, okay, and it draws real power. It draws real power. So it's a load, and you just think it is drawing maximum like large current, 16 amps at a time. So what happens is this voltage slightly may go down compared to the other two phases. So when this voltage goes down slightly, these two voltages may also go up of the other two phases. But how much will this voltage change? That depends on the type of grid it is connected, whether it is a weak grid or whether it is a strong grid. A grid is strong when it is connected to the transformer very near. When it is near to the transformer, the grid is said to be strong. Okay, and that in that case, the impedance is less, 0.2 or less than that. So the voltage drop will also be less. But you think of a rural area where the transformer is very far. This is the transformer, and you have small houses here, okay, and you have a charger very far in this house. They have an electric vehicle, you just think a two-wheeler or something, and it is far away from that. So in that case, what happens is the grid impedance will be high and the voltage drop will be grid impedance. So in this case, if you see the impedance is high, the voltage drop will also be high. Okay, somebody had a doubt? So this you can just search problem due to under voltage in electric vehicle. Many papers are there, and somebody is interested, you can go through, you can do measurements at your end. You can go to the places where charging stations are installed and you can ask those people, and you can just study these things, taking measurements. So that's one of the research. Over voltage is also found in many places. So let us take the same example. Okay, in over voltage, we know that nowadays solar panels are connected in all the houses, in all the offices and all, and mostly they are three-phase. Okay, so they are three-phase solar panels, or sometimes even single phase, depending on the thing. So these solar panels, they are generating stations, you can say, or they are generation. So in that case, it always tries to keep the grid voltage slightly higher, like it is at the higher point. And now you just think you are connecting a electric vehicle to any one of this system through a proper AC to DC converter, or like just I'm just doing. So you have an electric vehicle connected to this. So what happens? The electric vehicle tries to reduce the voltage and this tries to increase. So this gets nullified for this phase. Sorry. For this phase, it is okay. But what happens to the other phase when this electric vehicle is connected, when it tries to reduce this voltage, it slightly tries to increase the voltage in the other two phases. So this already increasing due to solar, and this is also increased. So it may result in an over voltage. Apart from that, while charging, some fault or something occurs, or many other issues are also there which are resulting in over voltage. So there are a lot of papers in over voltage also, not only due to this, many other issues due to EV charging also results in over voltage. So such studies are also possible in case of these vehicles. Then unbalanced, say during this time, like when EV PV combinations are there and power of EV is also varying, unbalance is also a major issue that can be seen, and many papers are there in unbalance also, that also you can go through. And harmonics, I'll be showing you some of the measurements harmonics what we have done. large number of harmonics are also seen. Most of these harmonics are within limit, but now you can see in the market many companies are coming into, so they are injecting lot of harmonics into the grid. Okay, so many local in India also, if you see, there are many local manufacturers there. So though they undergo all these testing and this, we have to be in track of these, because when more number of combinations come, there are possibility of interaction between these harmonics. They may sometimes resonate with the grid when these harmonic impedance match with the grid impedance, the resonance may occur and it may create problems. So those things are also to be taken into consideration. So these harmonics, if you see the power converter, if it is a 6 pulse converter, then the 5th harmonic and the 7th harmonics will be high. And in case if it's a 12 pulse converter used, then the 11th and the 13th harmonic. So mainly when you do measurements, you can see that these are the harmonics which are high. In different companies, they have different converters. Accordingly, it is different. Then interharmonics, that is also in electric vehicle, a very important thing which can be seen as the interharmonic, mainly during transients. What are these interharmonics? Say harmonics are the positive integers. You have one, like this is the fundamental one. So you 2, 3, 4, 5. These are the integers which are even harmonic, and you have the odd harmonics. Okay, so apart from this, you have interharmonics like say 4.3, or you can have 5.5. So these are non-integer parameters. So these non-integers can cause problem, and this is mainly when you are charging the electric vehicle, when during start and during end, or during the instant where there is switching in the power electronic, those times these interharmonics are seen, and interharmonics can also cause many problems, which we'll be seeing in the forthcoming slides. Then next is the supraharmonics. Supraharmonics are due to the power electronics. Okay, so you can say that these are the harmonics in the range 2 kilohertz to 150 kilohertz. So here below this range, we say it is lower order harmonics. Okay, and above this range, we say it as higher order harmonics. Okay, these are higher order harmonics and these are lower order harmonics. So before these, before actually generally if you see, we are more like all the standards are defined for this lower order harmonics, and in the electronic side for higher order harmonics also many standards are there. Since power electronics was not much during these period, they didn't define any standard for this range, 2 kilohertz to 50 kilohertz. And now when power electronics came, and most of the power electronics switching are in this 40 kilohertz or 10 kilohertz switching, what happens is this is injected into the grid, which is not being taken care. These limits are like, it is very much important that we have to set immunity limits for the devices, the converters which they are manufacturing. So because there are no standards, people are not having particular like filters for these, and they are leaving it in the grid. And many measurements have been seen. In one of the measurements, it was seen that in one of the paper, if you see, a solar plant is there, and around 16 kilometers apart, they could see the switching frequency of this solar like converter after 16 kilometers. Okay, so similarly in our laboratory also, we were seeing a component of 16 1/4. Okay, and we were thinking, what component is this? This was not in our laboratory. Then we found that kilometers apart there was a traction system, like a train station. So there that converter is providing the 16 2/3, I think 16 2/3 hertz key component, and then we found that it was propagated from there into the in our laboratory we could find. So these harmonics, they propagate through the grid. So it is very much important that we have to set standard for this. So if the standard is set, then automatically, because this is a higher range, a smaller filters enough to eliminate these things. So now the setting up of these standards are under like it is different committees are there in IEEE who are working on this. Different groups are working on it, and Professor Matt Bolan is also in the group. So that's why that whole group worked for this supraharmonics. And the term supraharmonics was also coined by Sarah and Professor Matt Bolan. So this is the range the group already working with, and mainly for electric vehicles also this range need to be set. And other things is these things like interharmonic, superharmonic, and these voltage variation create problems like light flicker. The flicker which I was showing is also due to these components. So that is also a very important area to look into. And then the local thermal overload. So that's also a problem. So here, this fast voltage variations are due to many issues. One is the compatibility check of onboard batteries, insulation test for output DC circuit, onboard battery protections checks, and voltage checks, CAN communication checks. All these things also create fast voltage variation in the grid. So I can show you some measurements which we can see. And these things create the problem of light flicker and many other issues also, like false triggering of power electronic devices and many other problems like RCD tripping. So these things we have to look into. Thermal overloading. Say nowadays also many people, they are getting these electric vehicles and they don't have proper like connection. They just connect it in our house plug itself. So what happens when large amount of current is drawn for a longer duration, heating out of those wires or thermal overload may occur. So many problems have been even coming out, like say one of the electric vehicle was purchased by a person and he had put it for charging overnight and the battery had exploded. So that is also, these may also be the reason for these overload, like thermal overloading effect. So many studies are required in all these areas, and many patents are also possible in these areas where you can come out with new technologies or new things for these protection thing. Because we say that yeah, everything is done, protection is there, but still in newspapers we can see many cases where such incidents are occurring. Okay, so that is also a very important area of research. Another thing is the measurements. What I was telling you, we did is in the ABB charger, that was a 160 kilowatt charger, okay, or with 375 amps. So it is a DC charger, the Chadimo time. Okay, you can see here, and this is CCS also can be used. So the CCS or the Chadimo, that is DC chargers are used here. And here your 200 amps Chadimo charger was used in this setup, and we did measurement here. So this was a 160 kilowatt charger, but for this 160 sorry 160 kilowatt, even say when it is only one single power converter, it was 160. But if with the same charging port, but if there are two converters, you can go till 350 kilowatt also with 500 amps. So that is the ABB Terra HP feature, where you can go for fast charging, still higher fast charging with this possibility. In that case, two power cabinets are required. Okay, so that is also possible. So this was the measurement what we did. It was for 1 month, and we got around 92 charging cycles. So these are different vehicles charging. Around 92 different vehicles got charged at that instance. So you can see here, these are the different charging, and they look different because they are different vehicles. And we had no chance of looking into which vehicle was it, because it's, as I told you, that was an area where the vehicles are charging which are not in the market. So it is all new power electronics devices where new topologies have been used, but those companies cannot be disclosed. So these are you can see some vehicle had taken 200 amps initially, then slightly they have reduced, and around 100 amps it is taking. So you can think this is a fast charger where it is taking more current. But some chargers you can see here. In this charger, initially it took 100 amps for some time, but after that with 50 amps, it is fully charging for a longer while. So that's what I said. The charger may be different, but it depends on the vehicle. This vehicle don't have the capability of fast charging. Okay, but it was connected to that fast charger, but it can draw only less current. So that's what somebody, when they were asking, that's what I want to tell. The charger may be any type of charger. This was a Chadimo charger, but the vehicle which came can be connected to that, but it doesn't have that power. Like that device doesn't have the capability of drawing such high current. It can draw only high 100 amps initially, and after that 50 amps. So that was the charging logic used there. Okay. And then you have these were the other like same thing, only it is little expanded. You can see here. So this is one of the vehicle with almost 80 amps. It is initially drawing and it is dropping. So here you can see the current is not constant, it is dropping. So they would have used CV charging technology, constant voltage charging. Okay, and that's why the current is dropping there. Here also you can see they have used a CV charging. So voltage dropped very drastically. But in some charging you can see, because these are different vehicles. Okay, so I'll be showing you some more thing where CC charging is also done. So that can also be seen. So different vehicles use different technologies for charging. So that is also not constant. Because one thing we have to remember, if we are drawing high current for a longer time, thermal overloading and many other issues are there. So you have to go for a logic where you're drawing large current for some time, and after that you have to shift into other things in order for a proper charging cycle. Okay, so here you can see this is the same 92 charging cycles, but this is the third harmonic component. And you can see here this is the peak values. Okay, so that's why high value of current is seen. Sorry, high value of current is seen here. Okay, and you can see some vehicle which was charged on 30th of March that had a very high third harmonic component. Okay, so it depends from vehicle to vehicle, the power electronics inside it. And we just wanted to see whether these harmonics are due to the vehicle or is it due to the background harmonics, like from which is coming from the grid. So we even measured the voltage harmonics, and from the voltage harmonics and from this the grid impedance was found. And again we identified to see whether it was the background harmonics, but it was not the background harmonics. It is due to the vehicle charging only these harmonics were seen. Okay, these are the fifth harmonic. So you can see that as the harmonics increases, the magnitude also decreases. The magnitude, like here you can see it has gone till 12 amps and all, but here it is 9 amps. It is going on as the harmonic order increases, it decreases, you know that. But it is not that, say, the same vehicle which was charged here had fifth harmonic, but it didn't have this seventh harmonic component. Okay, so it is not necessary that all vehicles will have all the harmonics. It again depends on what type of power electronics they have. So this is the 11th harmonic component. Still the magnitude has reduced, and you can see that different vehicles, more than this 7th harmonic was found in less vehicles, but this 11th is also found in more number of vehicles. And this is a charging pattern. Here you can see a vehicle. Here it is. You can see this 10 kilowatt constant power is there. Then step by step it is reducing. Okay, so different like here we have to see the current logic of this, whether it is a CC or CB. I think mostly it is a constant current charging, and after that here they have gone for a constant voltage charging, step by step reducing it. And this is also another car. So this car almost it took 1.5 hours, 1 hour and 30 minutes I think for charging, and this car took only 20 minutes for charging. So this was a fast charger. You can see around 50 kilowatt it has drawn initially, and in this car only 10 kilowatt. So it is taking only 10 kilowatt power. So it takes a long while to charge. You can see here the time almost 11, and this is 12:50 or something. So it is taking more than almost 2 hours it has taken for charging, or 1 hour 40 minutes, but this has taken only 20 minutes for charging. So it all depends on the power electronics connected here. And this is also another vehicle you can see here. And all vehicles you can see, before it starts charging, it does a check. So that's a current which you can see here. See, This one, this is initially it is drawing a current, and this initial current which is drawing, it also depends on the state of charge of the vehicle. If state of charge is high, then this current will be small. That also we noticed. Okay, and this is the waveform of that, and the same vehicle here. This is also almost a fast charger taking more current here, and this, in this case, if you can see, it is slightly current is slightly decreasing, and you can see the harmonics also when it is starting the charging and when it is ending. Harmonics are very high. Similarly, interharmonics also you can see very high values of current. That is mainly during the turning on and turning off. Here also, when the vehicles, different types of vehicles, you can see when it is charging or discharging. So like when it is starting the charging, you can see all these parameters. Okay, and here this is also another set of vehicle charging, and you can see the real and reactive power, because the power electronics inside is going on switching. So that's why this change in power can be, this can be noted. The reactive power is going on changing. That is because of the power electronic circuit which is changing. So yeah, inside that also you have LC combinations. So that's why the power draw, the reactive power change is seen here. Okay, so this is also, this is the same vehicle connected for some time, and after that again they had connected it. So such a vehicle here, it is a slow charging vehicle only, and you can see first initially when it was charging, it had a more than 50 amps it took, but second time when it was put for charging, it is taking only some 30 amps or something initially. That is because the state of charge of this vehicle has increased, and again they have put it for charging. And here you can see it is almost a constant current. So this is a constant current type charging. You can see the current is almost constant in this. Okay, and the different logics also you can see. So here is another vehicle. Here almost here it is constant charging. After that they have gone for CV, which is almost decreasing here. Okay, and this is also another vehicle you can see here. So mainly you can see here, you can see the pattern of when this is the waveform. So as such, you can see here, how did we identify they are a similar vehicle is with the pattern of charging, we can identify it. So you can see that initially it is drawing here during this time, it is constant voltage. Here it is constant current. Here also it is constant current charging. And this is the initial check current. And here you can see the harmonic patterns are also different. Whenever it is increasing high like this, it has a pattern, and the interharmonic pattern is also different. So this is also another vehicle pattern. This is another vehicle. So each vehicle has its own pattern of charging. We can't say that all vehicles have a same pattern. Okay, so this, like say in case if you want to find the impedance of the grid, what we do is say we have the voltage and current reading. If you just do the scatter plot of that, okay, and then draw the slope, you can find what is the impedance. So similarly, we found what is the grid impedance, and it was from the measurements, we found that our grid was a strong grid. It was the 42.8 milliohm. So it was a strong grid. So we did that with the same grid in case if it was connected to a weaker grid. We took a value of a weaker grid and we connected. We found that for weaker grid, the voltage drop would have been high. Okay, so such studies are also possible. You can just connect a vehicle with different like grids, and you can just see. So for example, say in India, this is a very important topic. You can go to a village and with an electric vehicle and try to connect it there and just try to take the measurements and see how much voltage drop it is creating in that area. Because in future, now also if you see in most of the villages, the scooters or electric scooters are there. People are started using it. So when more number of electric scooters are charging, what type of effect it is bringing into the grid, because there also it is 3.3 kilowatt charger only is used in two-wheelers also for fast charging in that level. So there also you can, a lot of researches are possible in this power quality side also. Okay, so now I think it's time. I think we have some more lectures. So during that time, I can cover this. I have a lot of things to talk about: harmonics, interharmonics, superharmonics. Let me look into. We have some more lectures which we can engage. Okay, so in that I'll be covering the other portions. So today afternoon we have a lecture of Ajay Godara sir. So he will be taking on this electric vehicle. So now since it is 1 o'clock, so lunch time, I'm just stopping with this thing, because tomorrow morning also the first lecture, I think ma'am is going out of the country. So because of that, sometimes I am trying to adjust the lecture. In case if it is adjusted, I'll be taking on some other day. But if it is not adjusted, tomorrow morning lecture I can engage, where I can give you more researches in this field, because a lot of different researches have been done in this. I can cover those at that time. Okay, so now I request all of you to sharp join at 1:30. Sorry, 2:30. The sharp that lecture will start at 2:30. So that's why I'm leaving now itself, so that you can, if those who want to go and have your lunch and come back, you can do that. Okay. So if you have any doubts, I will just take 5 more minutes. Ma'am,
Sir, I have a query.
attendance link not received. Attendance link I'll be sending. I think Gopal has to do it. I'll contact, because lecture was going on. I couldn't contact. That will be done. Ma'am, please share the PPT.
the motor parameters, motor technical details, like how much RPM is over there, power is there, voltage, and all these things that you can see it. Continuous torque and peak torque also, that you can get it from the datasheet of the motor. So that motor we have procured from the Indian vendor with the name of Compass Automations. So this one is a mathematical model. Over there we are going to use battery, braking resistor, inverter, and the PID controller over there. That is, we are giving throttle. So PID controller is being used over there for synchronizing it with the required power and and the speed also. So these are the different model that is being used over there, like motor modeling, and then after that you can see in the Indian condition, because when the motor is being designed, that is based upon the different country parameter. Like if something is being designed in the China, so they have designed based on their own parameters. But when we talk about Indian scenarios, because each and everything we are going to drive with the different loading condition, and overload we used to drive, like when we talk about trucks and when we talk about vehicles, two-wheeler or three-wheeler. So just take an example of two-wheeler is being designed for 2 person, but over there in the rural area you are going to find 4 people, 5 people, you are going to find those are sitting over there. In the same way you can see over there situation in the train. So in many places you are going to find those kind of situations. So whenever we are going to design the vehicle based on the Indian conditions, so we have to take care about all these parameters also, because sometimes there can be this situation also. So how that vehicle is going to perform in that particular situation, so that is also very important over there. Then you can see in the two-wheeler also you are going to find that kind of scenarios. So over there also you have to design that particular vehicle based on that scenario, that how your vehicle is going to perform certain test over there when we are going to run it. So the motor designing based on the power management, battery designing, all these things is being get done based upon the environmental or that regional condition over there. And in the one more way over there, like sometime when we are going to design vehicle in the plain area, and sometime we have to use that automobile vehicles in the hilly station also. So now in this day when we talk about those e-rickshaw, e-vehicles, those are not viable in the hilly stations. So why they are not viable over there on those areas? Because there are different terrain that they have to run over there. So we have to design in the customized way that is required, because in the India there are different terrain over there. So based on that, like in the rural area there is different road conditions. When we talk about hilly station like Himachal and Uttarakhand, over there is also the different terrain that is being used over there. So how you are going to utilize all these things and how you are going to design based on that, that is very important. Then after that you can find over there the different block diagram over there. Like this one is a block diagram of a machine or PMSM machine that you are going to find. These are the blocks that you are going to find directly over there in the MATLAB, because when we are going to design a complete vehicle, so that become very complex when we are going to design individual mathematical model. So you can use some specific model, those are already available over there in the Simulink library, that can be utilized over there, and based on that you can move ahead over there. So this one is a controller modeling, like when we are designing a controller over there. So that also you can see how that controller is working over there in that particular environmental conditions. So that you can check it out over there. So over there you can see earlier we have discussed, this one is a battery that we are going to connect over there, and after that you can find over there braking chopper, and then you are going to find over there like three-phase inverter, so that is required for PMSM motor over there. Then the position sensor over there, current controller, and then speed reference that we are going to provide it over there. So in that way it will go ahead. So this one is a mathematical model of PI controller over there. And this one is a gear model block diagram, like which one, how much gear, reduction gear works we have to use it over there. So that also can be get design over there in the same view. Now after that, this one is a e-vehicle loading condition model. Like when we talk about loading condition over there, that you can see in that way, like vehicle dynamics, how much drag force is required over there, and then after that we are going to use over there, like how much speed is required over there, how much air drag is over there in terms of resistance. All these things is being checked over there. Then after that we are going to talk about that complete mathematical model. So over there you can see this one is electrical drivetrain. So I'm just going to let you know first of all that how you can run that model, how it will work. Then we are going to coming back over there and we are going to discuss in the detail also that how that mathematical model will work over there. So now I'm going to show that mathematical model over there in the MATLAB. So be with me. So in the MATLAB, we are going to give some certain parameter that is as an input parameter, and we are going to simulate based on that parameter conditions. So based on those parameters, we are going to simulate over there. So let it open because we have to run it in the MATLAB. So over there, meanwhile, we are going to discuss about this one. So electrical drive model. So in the drive model, we are going to find over here, you can see like this one is like earlier we have discussed that model. This one model, same model you are going to find it over there. This one over there that you can see it. So then we are going to use this one is a braking chopper, three-phase diode rectifier, and then the three-phase inverter over there that is being get used over there. And then this one over there we are measuring. This one is a motor and current controller, speed controller, and these are the input output parameter that we are going to used over there. So all these parameter that is being used over there that you can see over there in a very simple way. So all the parameter like input parameter like battery. So over there also we can provide the voltage that is 48 volt and current rating, whatever the real battery that we have to use it. So you can use based on that one, and you can simulate that how much speed you are getting it, how much torque you are getting it, all the parameter you can check it out over there. And based on that, what you can do, you can uh, order you can give order about all the components that is required, like motor, battery, each and everything that you can get it. So now this one is like electrical motor model, like DC drive model. That GUI you can see it over here. When we are going inside of this model, you are going to find more detail about it. Like earlier we have seen that complete model of electrical drive model that you can see GUI, graphical user interface over there. So you are going to find battery, DC-DC converter over there, and then synchronous motor over there that you can see it. Now I'm moving ahead with the MATLAB. So we are utilizing one file over there, and that we are going to open it. So let it get open. So over there, how that is being get designed. So different component is being get assembled together, and one script that we are going to run it over there. The script is being get used over there. So this one is the script, that is the latest script that we can run it. Is we are going to run the script. That file is being get the complete that Simulink model is being get opened over there.
Jay, for the ones who are like starting now, is this model already available in MATLAB and where they can take it? Is this model available so that they can take it and modify it?
Yeah, that madam, I will let you know. Only basic part we are going to get it over there. Complete model is not available over there in the MATLAB. So I will let you know the another model you can get it over there from the MATLAB. That is hybrid model. So out of that you can convert that model based upon your requirement. So that I will let you know.
Take up some of the blocks which we require and we have to make our own model. Is it?
Right.
You.
So now over there, you can see this one is a complete model over there. So when we talk about input and output over there, so you can check it out. So first of all, this one is the input that we are giving it. So what is that? That is the Indian drive cycle. That is Indian scenario. Based on the Indian scenario, there is a drive cycle that you can get it from the government website. So over there, you can get Indian drive cycle, and you can simulate based on that drive cycle, because whenever the testing of the vehicle is being done over there, that is done based on the drive cycle. So there are you are going to find that IDC, that is Indian drive cycle, and one more drive cycle you can get it on the website of that Indian testing agency. So with the name of MIDC, that is modified Indian drive cycle. So based on that, you
we
can
have to go to the ICAT website and take it.
Yeah, from the ICAT website, and there is one more website that is IREI or something like that.
ARAI.
AREI. Yeah.
Okay, the Pune website. So they have already given some drive cycles which we can take it. Is it?
Yes. So they have made some standard drive cycle that is being used for the testing purpose. So on that particular website, the drive cycle is available, and the drive cycle is being used for the testing of the vehicle in real time also. So that same drive cycle, we are going to take it over here. Based on that, we are going to simulate it over there, that model, so that we can get some accuracy in the result over there. So this one is a control mechanism, like how you are going to control over there, how you are going to give input over there. All these things is being made over there in the control, because in the latest MATLAB, you are going to find that control in the Simulink, you are going to find control option over there. That is one add-on over there. Using that control, you can make your customized logic program. You can make it over there in the graphical way. So when we talk about control, then after that, these are the different model like electrical, and then after that vehicle dynamic, and we are going to get output over there like vehicle speed and all the different parameters that we can see over there in the scope. So when we talk about those model detail, that is graphical user interface over there. So we are moving towards more detail over there. So over there, when we are going inside of that particular model, electrical model, we are moving inside it. So over there, you are going to find two things over there. One, we have designed this one for hybrid model. Hybrid mean not just hybrid, that is for a regenerative braking option that we have add on over there, because when we are going to use that regenerative, so we have to add on separate motor to showcase that we are using two motors, and one motor is for regenerative and one motor is for just powering that tire or the shaft. So when we are using that mechanism in the real-time hardware, so over there we are getting all these things in the one motor, because when we are using BLDC motor, so over there we are using permanent magnet, and the configuration of that motor will suitable for as a regenerative mode also, as a generator mode also. So that can be used over there, but in the Simulink model we have to make it in a separate way. So both things we have to made it, and then after that we can simulate it based on that. So when we are going more ahead in the all the models, that you can get it over there like this directly. This model you can get it over there, motor drive model. So that is available in the library of that Simulink. Over there you can get it synchronous motor and drive. In the drives you can get it over there. So that is available over there in the library browser. In the same way, this one also you can get it over there, and you can select their parameters based upon your requirement. So that you can modify it also on the properties over there. So all the input parameter we have given using a script, not directly over there in the model. So we have used one script over there. All the input parameter is being given over there. That also you can give it. That is up to your requirement. Coming back over there, this one is a DC-DC converter. You can go about this model is also available over there. So the parameter you can see it over there. You can set your parameter based upon your requirement. Then after that, this
Ajit, we couldn't hear you. Are you speaking? We couldn't hear you.
Madam, am I audible?
Yeah, now it's audible.
Okay, thank you, madam. So over there, you can see this one is the battery parameter. So over there, this is the battery we have used. So when we are moving inside it, so you can get all the parameter of that battery, like how much nominal voltage over there, and all the setup you can do it, like which one lead acid battery you are using it, or which type of battery you are going to use it, lithium ion you are using it. So that battery type you can select it, their parameter you can select it over there, and all the discharge rate and all the parameter you can set it over there based upon your requirement. So then after, these are the motors. This one is a working as a generator. So their control mechanism, we are going to use it using that control that we have designed, that one we have to use that motor, and one we have to use that generator, because when we are not going to press the throttle at that moment, but we have to do it, we have to use. So at that moment we are going to use over there, that is one throttle is not pressed, one we are trying to press the brakes. At that moment, regenerative concept should be get started. So this one motor should start working over there, and this motor is being get used for this one is working as a generator over there. So generator we are using it over there, and that is being used for charging the battery. So because sometime when we are going to use the vehicle in the, like in the cities, or over there a lot of flyover is over there, so when the driver is going on the flyover, then the driver is using that battery power, and when the driver is going down at that moment, so regenerative is being get started. So with the help of that, battery is being get charged over there. So what will be the advantage over there? The range of the vehicle is being get enhanced over there, and as well as battery life also get enhanced, because when we are going to charge that battery in with a slow current rate, so the life also that can be get enhanced over there. So that can be get done over there. So now we are moving ahead over there. So this one is a vehicle dynamic. So we made over there different, like in the electrical also, there are three systems that is being get developed over there: basic, main level, and then system level over there. Like if you want to go ahead with some different motor, so you can make your model based upon the motor. So I'm just going to share with you another model. So detail models, when we are going towards more details, so over there we can go over there in this. So over there you can find more detailed over there, like in this you can see detailed motor and their parameters over there, like three-phase inverter, each and everything, the vector control of the motor, more detail you are going to find it over there. So earlier we have used basic model so that everyone can understand it easily. And when we are moving towards the detail model, so we have to go about the more detail about the development of that particular model if we are going to make it separately about all the component. So this one is a DC-DC converter. In the same way, when we talk about the battery, so over there also that parameter that is same in the battery is same. So over there also you can change it. When we talk about the battery, so in the battery also you can change it. So there are block choice, generic. In the generic, what you can do, you can define, customize based upon your requirement, that how much voltage, current, type of the battery, each and every parameter of that battery you can define it over there in this model, in the generic. These are the sensor, and that is customized, made, pre-made, not pre-made. You can make it customized based upon your requirement, and you can set all the voltage requirement, ohms, internal resistance, all these things in this model. So this one model you can get it in the library, and then after that you can add on all those models and buses and all the solver, and then you can get output over there. So that is the detailed model that we are going to discuss over here. So in the same way, when we are talking about the detail model over here, over there also, these are the basic control mechanism, electrical details. Over there, you can get all the logic, like as we are developing logic over there, you can see how it will work over there. Brake model, like when we are going to enable the brakes at that moment, our motor should enable, disable, start mode, and all these things that can be get designed over there in the control. So the motor control, all these things that you can see it, how the motor is being get controlled over there. About the input we are giving it, reference we are giving it over there, acceleration we are giving it. These are the input acceleration over there based on that drive cycle. So over there you can get like a different drive cycle, we can get it over there. So one is urban cycle 2, so that you can get it on that website. And based upon your requirement and based upon your testing, you can use any specific drive cycle. So currently it is connected with the urban cycle 1. Then this one is the vehicle dynamic. That is also very important. Now when we talk about this complete model of that mathematical model of electrical vehicles, so over there you are going to find many parameters. So the parameter that is being used over there, that you can see, we are taking input over there, control, we are using it, electrical drivetrain, we are using it over there, vehicle dynamic, we are going to use it over there. So many libraries required over there, like Simscape, Driveline, many libraries being get used that you have to install it over there in your system. Then you will be able to use it over there. So then we are talking about the vehicle dynamics. So over there, as we are going to open this model, we are going to find some parameter over there. And as we are going inside of this model, you are going to find like this, like aerodynamic drag, speed. So these are the basic parameter that we are going to give it. Now we are moving towards the advanced parameter over there. So the full model, when we are talking over there, so in the full model, we are going to get few more parameter over there, more advanced, like tire rotation, tire radius, all these parameter you can give it over there. This one is vehicle model over there. So mechanical model. So over there you can give inclination also, that how much inclination is required. Like when we are designing that vehicle for like hilly areas, so you can increase that inclination also over there. So that is up to your requirement. And the wind velocity also, that is the air drag impacting over there in the air drag over there. So all these things that you can give input over there. So left tire, right tire, then the gear ratio, how much differential gear you are using it over there. And this one is a differential gear that is required over there in the vehicles. And one more thing over there, that is, this one is a reduction gearbox. So which ratio of gearbox you are going to use it, like earlier as I shared with you that 1:10 gear ratio we have used over there in the vehicle. So that input is you have to provide it over there, and this one is the shaft from where we are getting input. So this one is a complete mechanical model that you can see it over there. So now what you have to do when we are talking about complete vehicle development, so over there you have to integrate all these models, and then after that you have to go to in the simulation mode and you have to run your simulation that you have to do it over there. So now we are going to just make it simplify so that the simulation can run easily over there. So the system we are going to select it over there. This one, let me take it full, and then after that we can start simulation over there. So the simulation is being get started. So we are just simulating for very small time over there. So some parameter issue is occurring over there. So what we are going to do, we are going to give input over there about the parameter also. So we are running a very basic model over there. So this one is a startup file. So over there in the startup file, all the input is being get taken over there. So we can open here this one with the startup file. You can get more detail over there. So in the startup file, all the input parameter is being get given over there, like all the vehicle parameter is being get taken. Now earlier there were standard parameter. Now the vehicle parameter is being get taken over there. Now as we are going to start simulation, let it check it out. So there is some issue occurring over there. Okay, let me change this one. Simple. Okay, that is good. So let me check it out, few more parameter over there to run it. So after running it, we can get the output over there in terms of the RPM, the input, like input speed we have given as a reference speed, and at the end we are going to get the speed in the big. So then we are going to compare both.
Tarun Narupa sir, can you please mute yourself? Tarun sir, yeah, thank you.
So let me clear all the parameter and let me take input again. Again, we are going to run that simulation. Okay, meanwhile, I'm just going to share with you the standard model that you can get it over there in the MATLAB. So that model also I'm going to open it over here. So that model is about the hybrid vehicle. So how that model will look like. So let me open that one. Okay, let me close it. Yes, now you can see over here, this one is a complete model over there. So in this model, you can get that electrical and this one is a control, similar, all the things are similar, but over there, one more thing that is being get used, that is engine. Engine is being used in the hybrid electrical vehicle model. And because this one has taken all the earlier library that we are using it, that's why you are getting all the basic parameter of electrical vehicles. So the engine is being get used over there, and this one is the power split device, which one is being get, working as a clutch over there. So whenever the engine is being get not used, so the electrical part is being get used over there. So during the starting stage, so or during the starting that we are going to use batteries over there, and that E part we are going to use it, electrical part we are going to use it, and during the synchronized speed when we are going to achieve it, then we are going to get use over the engine also, so that we can optimize the performance also. So all these things can be get done over there. So now I'm just going to use library over there because some library issue is occurring over there because the previous library is already in the path. So let me close it. Just we are going to rename it because multiple file is there. So let me restart the MATLAB. Some issues occurring with the MATLAB because it's showing some data error. So when we are running any model on the MATLAB, it required high configuration computer because there is many model, those are integrated over there, and also required some time also, because when we are going to run the simulation, it's a little bit hectic process because it's consume a lot of time over there while running the simulations. Sometime you are getting same error over there, so you have to modify the error, then also it's showing error, so you have to restart your MATLAB. These are the few things that you have to take care while running any kind of model in the MATLAB. So whatever model we are making it over there, that model you can deploy it on the hardware also. Okay, let me go again back. Okay, these are not, files are not in the path.
Ajay, are you there or you got disconnected? Participants, 1 second. I'm just calling him. Might be he has got disconnected. 1 second, we'll check.
sorry for inconvenience. There was some network breakdown. So, am I audible to all the participants now?
Yeah, you're audible.
Okay, madam. Sorry for inconvenience. So coming back over there, so we were checking out about that model. So this one is the model over here. So we are going to check it out, the parameter of the scope. In the scope, in the car scope, we are going to check it out, the basic parameters like accelerator, how much accelerator we have pressed based on the input parameter. So the input parameter that we are going to take it, that is the drive cycle, and how much speed output we are getting it, the motor torque and all these things that you can check it out over there. So as we are going to start simulation again, so we can check all the parameter. Simulation is being going to get started now. Simulation is being get started now. You can see motor, generator and the battery. So power that you can get it over here, these are three powers, different power, and these are the input, drive torque, and this one is the vehicle speed output. We are getting it over there. So this one is a drivetrain scope over there. So you can get different parameter over there in the scope, and you can check it out. So this one is the RPM that we are checking it over here. So let me run that simulation again. So over there we are not getting too much data. So let me show a few more parameter over there. This one is the IC engine scope over there. So we can get some more parameters over there. So in the same way, like over there, our scope, demand, vehicle reference speed that we are using it over here. So over there in the scope, we are going to check it out, the acceleration over there, like input and output over there. So the two different parameters. So 3-4 parameter we are getting it over there in the different input from the different situation over there. So the PID controller is being used based upon the input data, that this one is the vehicle speed and this one is the reference speed. So both is being get compared, and the feedback algorithm we are using it over there, and KP and KI is being get set based upon the requirement, and we can get based upon the output over there, the acceleration over there. So all the parameter we can check it out over there in the scope, like we have seen over here. And in the same way, if we want to see any specific parameter inside that particular model, that also you can see in the scope, and based upon that you can evaluate your model, that it is performing based upon the requirement or not. So what parameter we have to modify it, like over there we want to modify the input parameter, we want to modify motor parameter. So all these parameters you can modify it, based upon that you can run your model. So now I'm just going to open that previous model. I think that will work fine now. So now the simulation is going on over there in this. So simulation has been get completed and we are getting results over there like in the same way. But over there we have not used that engine model, only the vehicle model that is being get used. So the input parameter you can give it via script. So I'm just sharing with you that script that we are going to use it over there. So all the input parameter is being get taken over there. So the different script we have used over there. So the script that we can get it over there, all the library file that is required for this one. So the library is being get added over there, and the script data you can get it over here. Like all the parameter is input we have given over there. Like we can model set a system. Then after that model configurations, model test model. So all the different input parameters being get given over there. Fuel that is not required over there. So few more parameter like check scope, all the scope data. These are the cycle, urban cycles. So when we are talking about the urban cycle, so you can get input parameter over there in the MATLAB. That is the like different in the different time, how much acceleration we have given, how much speed is being get received over there. So that parameter you have to create separately. So when we are going to use some specific drive cycle, so based on that you can give as a input parameter. So then after that you can run, or you can give as an input of all the parameter. So we have used one standard file that is startup model. So in the startup model, all the library is being get imported over there. The library path is being get added over there. All the image that we have used over there. So the path of the script data, reports, power quality, sim results, all the path is being get given over there. And then this one is the parameter that we have given as a input over there from the file that we have created over there. So the parameter is being also get added over there in that way. So these are the setup configuration. Like if any configuration that we want to set up it, that also we can set up it over there, like battery type, which one you are using, predefined or generic battery, electrical model, system level model we are using it, or the standard one we are using it, system mean and advanced model. So three model we are going to get it over there, like system mean and detail model. So that we can select it over here in the configurations. So all these things is being get added over there. This one is a very hectic task, because combining all the script over there in one specific folder and different file you are running it, then you can execute it. Otherwise, what you can do it, all the input parameter, or you can give it directly in the MATLAB. So in the MATLAB, as we are going to enter over there, so all the parameters separately one by one, if you want to give, just what you have to do, you have to open it and you have to remove this path. This one is the path. If you want to add on like input parameter, you want to give it with your own, so you can directly enter the value, which one is like how much that vehicle mass and vehicle area, so that you can select it frontal, that is frontal area over there. Air drag is going to put the impact. This one is a drag coefficient that you can select it. Then the of the vehicles, then the gear ratio that we have used. So all the parameter you can give it over there. And let me go inside it. As we are going inside over there, also you can give separately also all the parameter is an input parameter. Like gear ratio, how much that is required, that you can give it separately, or all the complete block parameter you can give it from the outside also. In the same way, electrical also, if you want to give a parameter as a input one by one, that also you can give it. So over there inside it, you can go and you can give your parameters wherever you want to give it. So we have given all the parameter using the script file. So that also, the drive cycle also, you can give it like manual input also, you can give it over there. That is up to your requirement, that for what application you are making it. In the same way, you can make your mathematical model, you can check it out, you can simulate it, and you can evaluate your result. Now over there is whatever result we are getting it over there, that can be compared with the input, whatever input you have given, and you can change the parameter of the motors, vehicles, dynamic, tire radius, all these parameters also you can modify it based upon your requirement. So now I'm just going to share with you a few more results over there, so that you can get understood that how we have to compare the results over there. So like as earlier I shared with you, like these are the input parameter. Manually also you can give it over there, like mass and the number of wheels. In that way also you can give it. So this one is a complete model over there. So over there, all the electrical control and simple vehicle dynamic model also can be seen over there. So these are the input we have given over there as a reference while the simulation condition. Now I just share with you one drive cycle we have used, but you can give step input also over there. It's not necessary that you have to use that IMDC drive cycle. So you can give like input magnitude of 20, 25, 30, and the loading condition we have taken it like this. Unladen weight and with laden weight, so total weight is like this, and we have given these are the input. So when we are going to compare the result over there is the output, that you can see it over here, like this one is the input we have given. These are the input that we have given. You can see over here vehicle reference speed is the input we have given, and this one is the output that we are getting it over there. So there is a lag over there that you can see it. That is a like if the motor is not optimum, so that lag will you will find more. So if the motor is optimum, so that will be very less gap over there that you are going to get it. When the desired is very close to the set speed. So there is different input, like over there you can see it like 30, then 25 and 20. So three value we are using it over there, like 1, 2 and 3. And these are the battery state of charge. That is also very important, that how your battery is going to get drained. If your vehicle is not optimum design, so it will consume more battery. Like if the vehicle is running in the overload conditions, so that you can check it out over there. If the vehicle is running in overload, you have given throttle and vehicle is taking time to achieve that speed and not achieving specific speed, it means the vehicle is running overload condition and it's consume more power. And when the vehicle is consuming more power, battery is being get drained faster. So that battery state of charge also you can check it out over there in the mathematical model over there. So what is the state of charge over there in the battery? Like that should be like this, but there is more drainage over there in the battery, that you can see it over there in the different speed conditions. Like when we are going to move ahead with the 30, so you can see like this, and these are the 25 and 20. So that you can see it over here. And these are the IMDC that drive cycle that I have shared with you as the input that we have taken it, and over there we have checked out the performance. So how the vehicle is moving over there with a lower speed over there, and when we are going to increase the speed over there, so you can see the vehicle is achieving maximum speed, that is 25. So when we are giving more input, it will not go at that speed. So what we have to do, if we want to increase the speed of the vehicles, because that is desired speed was approximate 30, so we have set it based upon that. If you require higher speed and you are giving higher input, so you have to increase the reduction gear and as well as motor power and battery power. So all these three parameters you have to increase it, and based upon that you are going to get more speed as input also over there. But over there cost is also very important parameter that is being get added. So as you are going to increase that particular speed, so that also going to impact over there the vehicle life, vehicle cost and battery cost and motor cost also. So over there, that is battery state of charge during that IMDC drive cycle. So based on that, you can draw your characteristics over there, like when we are using IC engine over there, so weight by power ratio, that you have to calculate that where it is performing in the best way. So when we are going towards the hybrid, so over there we are going to check it out, power by weight ratio, and where it will work in an efficient manner. So the optimum you have to select it, ideal power output you have to select it, and ideal torque you have to select it, which will fulfill your requirement. So that is the comparative study that we have done over there. So like the battery we have used, that is lead acid. You can use lithium ion also, but that is a little bit costly. That is the issue. So that is the battery study, selection of the tire. All the tire is being selected wisely over there while taking their parameters, requirement, and the design calculation. So the speed calculation, drive resistance calculation, torque calculation, all these calculation you can do it separately also. Based on that, you can calculate speed, and then after that gear ratio you can select it. So there are different gear ratio is available. So if you want to achieve more speed, you can reduce the gear ratio, and based on that you can achieve more speed over there. So that is drive resistance calculation, gradient resistance. So these are the calculation of the vehicle when we are going to design it. Air drag, how much is required over there, inertial drag, that is the mathematical calculation on the paper. So when we are doing it, so all these things you can do it in the simulation also. So torque calculation, that is the all the theoretical things, and then after that we have integrated all these parts, motor, gearbox, and all the part is being separately designed for the interfacing of the gearbox, reduction gearbox, and after doing all the assemblies, so it will look like this, and then we have tested the vehicle in the using weighing machine over there, where is that, and that calculation, all the as per automotive industry standard road worthiness is being calculated over there using free run, no load condition, full load conditions, how much acceleration we are getting it. So whatever we did it over there in the mathematical model, that we have tested out over there in the hardware also over there. So how much speed we can attain over there, how much range we can attain over there in the vehicle, that was approximate 110 kilometer after one charge, and the total vehicle mass is, that is 838 kg. So these are the different gear combination also, like when we are going to use combination 1 2 3 4, like 8 ratio 1 ratio 8, 1 ratio 10, 1 ratio 13. So how the vehicle speed is being going to get perform over there at the time that you also you can see, and battery state of charge also. So when we are using higher speed, so it will also drain more battery. So optimum gear ratio we can select it over there. So that we have selected 10 ratio 1. So 10:1 was the optimum over there based upon the all the mathematical modeling and the calculation. So that is about the brief about the result and discussion. So there is a lot of future scope over there, like we are working over there on that solar integration over there. So that also can be integrated over there in the rooftop, so that you can increase the efficiency of the vehicle also, like fast charging also. There are many options, many scope over there. Over there it can be worked. So same model we made over there for the two-wheeler also. In that way you can go for two-wheeler modeling also, and you can deploy it on the hardware also. So now I'm coming to the question answer. If you are having any kind of doubt, any kind of queries, you can feel free to contact me over here. These are my contact details, and now I'm taking your queries.
So participants, if you have any doubts, you can ask. Ajay, once again, like you were telling about that calculation, I just wanted that to be a little more clear. So where to start with, like you were telling about the diameter of the wheel and the weight of the like mass. So all these have to be calculated and put it into the simulation, is it? So where to start with? How first, like, is it like how much load it can take? With that, you start the measurements, or like if a person who is newly going to start, so how will we design the first? What are things he has to take care, and then step by step how to go forward?
Yeah, for that matter, first of all, we have to take some reference vehicle if we are going to make some advancement in the existing vehicle. So, like there are e-rickshaw, we did some survey over there. We took some parameter of those e-rickshaws, and we have entered on the Simulink model the basic parameter of those e-rickshaws. Those are available with us, and then after that we have seen that those parameters are optimized or not. Then we have moved ahead with like we have increased the weight. Then we have checked out that how the vehicle is performing based on the higher weight with same power rating of the motor and all that. Then one by one, that is the hit and trial method that we did it. And second thing is that we have decided some parameter over there, like we required this much weight we have to carry with that vehicle. So laden weight and unladen weight that we have decided. Based on that, we did all the reverse calculations, and then out of that we are getting all the power requirement, how much power is required to that particular tire, and power on the wheel. And then after that we come out with the, if we know that how much power is required, based on that we can select the motor. First we have to select the motor, then we can go with the battery also. If the power is required in that particular motor, that how much voltage is required, then we have to check it out the range, how much range is required. So all these parameters we are going to freeze, like first one is the how much weight we have to lift, how much range is required over there. Then in the reverse calculation we can come out with the battery requirement, motor power requirement, and the unladen weight and all that parameter we cannot control because when we are designing it, so that is about the mechanical design part. So over there we have to take that standard one. So based on that, we can start from the scratch and we can come out with some concluding points.
Yeah, so what I understand is, so even with the electrical parameters, we have to know about the mechanical parameters and fix everything, then we can do it. And that model which you showed, the hybrid model, is already there in MATLAB, is it? So you modified that for the electric vehicle, pure electric vehicle.
Yes, madam.
Okay. And I just, from the participant side, because many were messaging also that they want this model. So in case if you can share it, the PPT as well as the model, will you be able to share the model with the participant?
Yes, I will share that model, that hybrid model I will share with the participant.
Yeah, thank you. So participants, you will be getting the model, so we'll be sharing it. And I just wanted to know, if it is a model in MATLAB, then why do you want all these supporting files to be kept in your current folder? Like, is it not there in the MATLAB link itself? Like, or you created these?
No, madam, that complete model is not in the MATLAB, but that is the separate different model. Model is not developed by the MATLAB.
Okay.
So that is developed by any other person. So that we have imported over there, and all the supported file is included in that particular folder.
Okay. Oh, so it is not like it is from file X to somewhere else you have taken and
Yes,
you have modified it.
Yes,
Okay, so
that is not like all the model is available in the MATLAB and we can directly run it and it will work over there, because all the few parameters we have to take it over there, then we have to club it in the one file folder, then we have to run it, then that model will work. Sometimes the version is also important. So based upon the model, like which one MATLAB version your participant are using, so what I can do, participant can ping me in the WhatsApp that which one MATLAB version they are using it. Based on that, I can make it compatible and I will share with the participant.
Yeah. So if some participant who's actually working in this area and you want that model to be in your MATLAB when he wants to share, because he can just save it in that. So I will just request you, for me also, I to require it. So 22, I think my MATLAB is 21, I think. So in case 21 A or B, let me just check it. So if you can share.
Surely, madam, I will share with you compatible for 21 the 21.
Yeah, 21B is my model. And if participants, if you also have any requirement, he can share the electric vehicle model as such. That will be useful for us. And one question is that, sir, for hybrid hybrid energy storage system, battery and supercapacitor fuel cell, is there any standard ratio to be considered, or in general, would be the economical ratio of how hybrid energy storage system for electric vehicle. So I think like it, see, capacitors has a particular rating. You cannot go above that. Set like then the capacitor will become bulky. So mainly when it is going uphill or downhill, like when regenerative braking is done, I think these super capacitors are used. So might be, is there any ratio, sorry, any standards for this?
So, madam, that is there is no any standard, but we can check it out in the simulation that when we are using it. So how performance we are getting it over there. So in the MATLAB we can add on like that fuel cell and capacitor, and we can add on solar also over there. So solar module also those are available in the MATLAB. So that also can be get integrated over there for the charging and all that.
Sir, one more thing I want to ask. The model which you have created in the like that hardware model that we have implemented, and so you increase the performance of that particular electric vehicle, right, sir?
Right, madam.
So how much percentage has been increased by this technology that we have adopted?
Yeah, so using that, earlier we were getting the range of the vehicle based on the all the like motor we have used earlier. So that was approximate 70 kilometer in one charge. But after using this technology, we have achieved 110 kilometer per hour. That is the range. Sorry, that is the range total kilometer in one charge. 110 kilometer in one charge. And also we have increased the vehicle weight also mean that unladen laden weight mean we can carry more weight also with that vehicle. So few add-on we did it, and we have enhanced the range of the vehicle.
Okay, sir. Can you share that particular file, like charging, what you have made, the charging topology and all these things?
So charger we have used standard one. So we have not worked on the charging. So the standard charger we have used that is required for lead acid battery. So using that we have charged it, and then after that we have tried it in the different conditions like loading condition, unloading conditions. So with the loading condition we have achieved the speed that we have evaluated over there. So the charging is the different part. So that depend upon the battery life. If you are going to charge it in a faster way, so that will impact the battery life. So that will depend upon the battery requirement and how you are going to adopt which one topology over there in the charging. So that is the separate part.
Okay, sir. Thank you, sir. Sir, if possible, please share your work with us so that we
Yeah,
can.
surely, madam, surely.
Thank you so much.
And so one more thing I want to talk, like when you were showing that with the earlier without any improvement, the speed was different and tracking was only 25 or something. You had kept a speed of 70. So what, like, is it this improvement what you said, like the weight, latent weight, all these things you changed, or what are the parameters you changed in order to achieve that original speed of the drive cycle?
So when we talk about the original speed of the drive cycle, in the drive cycle there was speed higher also like from the 30, but we have to limit that speed to the 30 maximum. So based on the parameter that we have taken, and we have achieved maximum 30, so we didn't went beyond that. But when we are using that hybrid electric vehicle model over there, you can find that the battery capacity is different and battery parameter is different. Many more parameters you are going to get it over there, that is different.
Okay, so here you wanted only 30, so accordingly you designed it.
Yes.
You didn't want your vehicle to go at a higher speed. Yeah, it's inside the campus only, and now also it has been.
And also at that moment there were government guideline that you can run your electrical vehicle with a speed limit of 30 maximum. But now that is being get revised, and now we can design the vehicle with a higher speed also.
Okay, okay. So that's the reason that it was tracking that. Okay. Any other participants? If you have any doubts, you can ask. We will get the model from him, and this calculation also we can get. Yes, sir.
Yes, sir.
Good evening, ma'am, sir. I have one question in that.
How do we monitor overcharging or over-discharging?
One by one, I think first is it Kumar Vaibhav sir is asking, and next person. First, yeah, Kumar Vaibhav
Yes,
sir,
ma'am.
you ask. Yes.
Thank you, ma'am. Thank you. Ma'am, I have a question. I mean, people are talking about the regenerative braking, and number of research is available for regenerative braking. and even the battery and supercapacitor model is available for that. But manufacturer is not adopting such kind of model. What is the problem in that, man?
So the major problem is that when we talk about electrical vehicle, those are being get manufactured in the India. Those are not just manufactured in India. Those are just assembled in the India. All the component is being get imported from the China. All the controller and each and everything, and we are just going to assemble it and we are going to sell it over there in the market. So no one company is working the research part of that particular vehicles. They are just going to assemble it and going to sell it. So the highly required now in these days, as I told you in the beginning also, as per Indian market scenario, road conditions, we have to design the vehicle so that we can enhance the performance. As I said with you, detailed comparison of the current vehicle, existing vehicle, and we have developed over there the vehicle. So there is a huge difference in the range and performance over there. Why is that? Because we have designed each and everything based upon the Indian conditions, and optimum design we have opted it, and then we are getting good performance over there. But the Indian scenario, when we talk about industries, they are not having that much facilities and the research support. With the help of that, they can deploy it and they can run based upon the new topology, new technology that is being already available over there.
Yeah, I too want to add on. Like one thing is a fuel cell, it's little costly nowadays. So as technology improves, these fuel cells can also be added. And you were telling about the supercapacitors. Now people are working on these supercapacitors, but you know about the capacitors. If it bursts, there is a chance of fire in the vehicle. So safety is also a very important matter. So lot of power electronics for better, like once the technology is developed and it is in the full form, then only they can bring it in the market. But now in the initial stage, if it comes, then we also know, like many a times when nano started, many people found that nano was burning in one place, another place also, like many news came. So whenever such technologies are coming, these are more sensitive ones, because it is involving human and we are going to use it. So we can't say that there are no vehicles. Even the supercapacitor, like last time also I called one of the experts from NIT Calicut. They, in their campus, they have done this supercapacitors, but they are trying to have that hybridization of battery and supercapacitor. Now what they are doing, their campus is full uphill, so they are with supercapacitor itself, they are running, and they said around, like say, half a kilometer they can run, then again they have to stop there and charge it. But they are also trying to develop some power electronics where this combination can be done. But it will come. It is not that it's not there, but might be a soul proof technology they want, which is more safer and like such. So that's the main thing. So but in near future, the supercapacitor with battery combination will also be coming in market.
Yeah, and more research institution has to integrate over there with the industry. Like whatever they are developing, they have to not only make it in the theoretical way, like in the Simulink only. They don't need to limit it. They have to deploy it on the hardware. They have to test it over there, and then they can transfer the technology to the industry also. So that automotive companies, those are manufacturing vehicles, they can adopt those realistic technology. Those are in the working mode, so that would be easy for them to apply it. Otherwise, when we talk about only the theoretical things, they never rely on those things.
One more sir was asking, like actually there was a confusion. A lot of people were talking. So now who was that? Sir, are you there?
Yes, ma'am. Yes, ma'am, I am.
Yeah. Kumar Vaibhav sirs, I think he has answered. Like one more sir was there who was parallelly talking with you. I thought like I'll call him next. I think, is it Murugeshan sir?
Yes, ma'am. Probably.
Yeah, so somebody else was there. I am not sure who was that. Anyone else want to ask? You can ask.
Madam, good evening, madam.
Yeah, yes, sir. Yes, sir.
So I am Anandagurthuram, Hindustan College, Coimbatore. So which motor is best for electrical vehicles in our road conditions? So a lot of motors were used for electrical vehicles. For our scenario conditions.
Say like tomorrow we have a session fully on that. Sir is fully working with electric vehicle, but what, according to my suggestion, permanent magnet synchronous machine is good. But according to the Indian scenario, getting permanent magnet is a problem. So that's the thing. So now many researches are going on in the field of induction machine, induction motor, trying to have characteristics which are similar to this. And many researchers are going in different field. Even DC motors are also good, but and even switch reluctance motors are also used. All like, but the best one nowadays it is in height is the permanent magnet synchronous machine. But in Indian scenario, people are trying to develop an induction motor with same characteristics, because the manufacturing here of induction motor is, I think, might be simple or something. But I think this answer tomorrow, like we have Ravi Teja sir, whose PhD is in this area. He's in the area of drives, and he will be a better person to answer this question.
Okay, madam. Thank you. Thank you.
And anyone else? Even we have like battery management on tomorrow. Let us see. Let us explore how much we can extract from all those experts. So any other participants who want to ask?
Excuse me.
Yes, sir. Yes, sir.
How to monitor overcharging or over discharging and temperature of the battery? How to monitor now?
So all these things with sensors only, you have proper battery management system for this. For like say state of charge, the overcharging and all these things with state of charge only. State of charge, to determine that, you have many methods, many proved methods, as well as many when we talk about students doing here, they don't go for high-tech methods, but they are in the initial stage looking into the voltage, seeing how much is the voltage. But there are very good methods, especially for these charging, so determining the state of charge. And all these things which you ask about the battery, like about the temperature, everything comes under the battery management system. You have special sensors, and all these sensors, you take the data and you have to just analyze it and determine, yeah, now the value has gone overcharging, because proper cutting is there. When I morning also I said CCCV charging and all, when it reaches that, when the voltage goes down, you do trickle charging and you try to maintain it. But in case overcharging is occurring automatically with the current as well as the voltage rating, you can determine, and you can disconnect, or you can stop charging for that many. But anyway, again, this question I think tomorrow we can ask while the battery management class is being taken. So let us see how what type of answers we can get there.
Okay, ma'am.
Any other person who want to interact or ask something to Ajay? Because the modeling and other portion, I have just asked him to share his PPT. I think the last portion he couldn't because of the time. Otherwise, he used to clearly explain each and every calculation of those, which was really very interesting. So anyway, he's sharing his PPT. So like you can see the calculations, and how taking these calculations you can enter in the model also. So, and he's ready to share the thing. I first of all thank Ajay for sharing the PPT and the model also. I'll be sharing with all the participants. And if there is no question, I can just wind it off. Yeah. So Ajay, once again, I thank you for joining with us and delivering this lecture, for clearly explaining the different parameters which have to be entered into these MATLAB models. And as you said, I also have searched for these electric model, but this model seems to be more prominent with all the parameters added in it. So this will be a useful thing for our students also who are working in this area. And thanks a lot for sharing this. And please share all the files. So we'll try to put it in the drive, or you can share the drive link itself. With that, we can send it to our participants. And once again, I thank you for joining with us.
Thank you, madam. Surely I will share with you all the files.
Okay, thank you, sir. Thank you. Okay, participants, tomorrow at sharp 9:30 we will meet. Okay, and thanks for joining with us.
Thank you, madam.